That's for Israel. Wonder, is it real? Rappers acting say they high, say they sip with pills. Glorify suicide so they get the deals. Big pharma set it up, had to flip the pills. Control the music industry until the scripts get filled. Geopolitically, yeah, we in the field. That's for Israel. Wonder, is it real? Took the way you saw the world, then distorted it. Now you think you wanna rock that twirl somewhere orbiting. Theories disproportionate, the truth distorted quick with a forceful grip. They force a misinfo that we absorbing quick. Took the people's signature to mean extorted it. They forging it. If news ain't good informant to informing them, there's a surplus, but they tell us there are shortages. Credit economy mortgages, dollar that's supported with empty fortresses. But what's important is this: we courting ships, important gifts. Of course it is, but extortion is in accordance with an assortment list of foreign tricks we ignoring, which informing this, informant this. It looked like we were snoring tricked. Pedophilia and the government endorsing it. Yeah, eugenics is exactly what abortion is. You just vilify those insubordinate. Way to matrix engineer, that's unfortunate. Geopolitically we in a field. That's for Israel. Wonder, is it real? Rappers actors say they high, say they sip with pills. Glorify suicide so they get the deals. Big pharma set it up just to flip the pills. Control the music industry until the scripts get filled. Geopolitically, yeah, we in a field. That's for Israel. Wonder, is it real?
On the YouTubes, I'm known as Professor Parks, PhD. In my professional life, I'm Dr. Rob Parks. I am the operations director of the George Mason Observatory. My focus these days is in education, public outreach, that sort of thing. My research interests are exoplanets, star spots, and young stellar objects. So, yeah. Dr. Bennett?
Oh, okay. I guess the relevant part of my history would be that I was educated, or probably better stated, indoctrinated into mainstream physics, including master's and PhD. Ironically, I did my thesis on general relativity, relativistic rigid body motion. I've taught at colleges and followed the mainstream doctrines. But in the course of teaching, I've had the chance to evaluate the belief system of mainstream physics, and I've found that there are significant cracks in the magnificent edifice that is being proposed to us by all the mainstream elite. And so I would summarize my beliefs by saying that I believe in a geostatic universe, that is one in which the Earth is at rest, and that's speaking dynamically, not kinematically. And the other important feature, I guess, is that I believe that there is a fundamental substance from which everything we observe is created, called the ether. in that it can be observed in different phases, just like water can. And probably the most ignored and most significant part of ether is the effects it has when it is in motion. And there are plenty of experiments to show that. Well,
Okay.
I've probably already said too much, so let me cut it off at that.
Well, cool. Let me jump in right here then. And so technically, I guess I will quote unquote moderate. I don't really foresee that even being a thing. You know, I've engaged with both of these individuals multiple times. They're both professional and courteous. But need be, say this conversation may get a little spirited. I will try to, just kind of bring it back down. If anyone needs some moderation, feel free to say something. I think that it's just going to be a pretty chill format. It's an open discussion. So yeah, I guess that's kind of where we'll go. We'll just open it up if you guys want to just start discussing things, and if we get some over talking, or I feel like some people are maybe dominating and not being concise enough or whatever, I'll try to kind of rein it in. But other than that, I plan on kind of just staying out of it.
Also would be good. It also would be good to know what tests or experiments were were being considered for presentation, so that we didn't have any gotcha moments where one person brought up some little-known experiment or test in order to, stir the pot, as it were.
Sure.
But I don't think there'll be any need for moderation, Austin.
Yeah, I kind of agree. It's just an excuse to stream it. So.
Okay.
Fair. I just want to make sure, is my sound good? I believe Riggs had mentioned that my mic sucks.
Gain's a little bit high.
Gain's a
You
little
can
bit.
lower the gain a little bit.
But overall, yeah, your mic is good. We have audio autists, so.
Oh, dude.
How about now?
You're good, brother.
That's much better.
Much better.
Wow, no, now it's good.
Yeah,
Before
night
it was
and day.
not.
Night and day, bro. Let me tell you.
Okay, good. Yeah, I've been moving things around, and so I think the gain on my mic had bumped. So,
to cover one more thing, I guess. So if someone is wanting to share a screen, I think you probably both know how to use that function here in Discord. But I think that Alan's going to share for Dr. Bennett, and then it'll show to the stream. So if anyone wants to pull something up or reference something, or want us to pull something up for you to show the audience, just let us know. We do have the ability, of course, to share the screen through Discord to the audience. So just a reminder.
Okay. So, if I might, I would like to ask Dr. Bennett. You know, obviously, there's geocentric, but I have not heard this concept or the term geostatic. Can you define that better for me?
Okay, I will do that if you promise to define geocentrism.
It's not my position, but I can define it as I have heard other people define it.
Okay, geostatism means that the Earth is at rest compared to all of the other observable objects in the universe. We know that if we observe the heavens, we see everything is in motion, with one exception. So everything is moving relative to the Earth if we observe the sky. And there is proof that this is true if we go back to Principia, 1687, where he made the magnificent claims, the first three laws of motion, Newton's three laws. But he was such a brilliant man that he also realized that there were exceptions to his laws. There were situations in which the laws were not obeyed. And one of them was the Newton's bucket experiment, the Donkin. So if you're familiar with that, you know that if Newton in his lab makes measurements of water in a bucket, which is rotating at the same speed as the bucket, he will apply the centrifugal force law, which is mv squared over r, and he will predict that there will be an outward force which will cause the surface of the water to creep up the sides and form a vortex. And indeed, that prediction, which is based on a law of physics, is correct when we do the measurement. We do see the curved surface, the vortex formed, when Newton, in the lab frame, applies the laws of physics.
Yeah.
So he is making a prediction, so we're in dynamics, not in kinematics. The observation of the state of the surface of the water, that's kinematics, that's measurement. Prediction of what that water surface will do through the laws of physics is dynamics. So we must have an understanding. Yeah, we must have an understanding, Dr. Parks, of the critical difference between kinematics and dynamics. The first choices you have to make when you decide on physics as a career is, am I going to be an experimentalist or a theorist? And that's basically kinematics versus dynamics. All right, getting back to Newton's bucket. If we consider that there's a person on the bucket, firmly attached to the bucket, as it's spinning in the lab frame, let's call that person the bucketeer. All right, he applies the laws of physics in the same way that Newton did, except that he sees the water, since it is rotating at the same speed as the bucket, he sees the water as having a rotational speed or a rim speed of 0. So he applies the same law, centrifugal force law, and he inserts V in the mv squared over r and gets 0. So he predicts that there will be no force on the surface of the water, and he predicts a calm surface, a flat surface. And yet this is not what is observed, because what the bucketeer observes is exactly what Newton observes. There can't be a conflict because one person in one frame can't see the water forming a vortex, and the other seeing it flat. So the bucketeer fails in applying the laws of physics. Now,
Okay.
Dr. Parks, do you know that there were two theories proposed, one by Newton and one by Ernst Mach, that attempted to describe the situation?
Yes.
Okay, you're familiar with that.
Yes.
Okay, let me go through the two situations.
Okay. Actually, if I may, you have defined, let me make sure that I'm not misunderstanding you. You define kinematics as the physics of stationary objects? Is that?
No.
Okay.
No.
Sorry. Could you go over that?
No, I define kinematics the way I think everyone else does, at least in the books that I read, that it's measurement. As an astronomer, you know that one of the first art or divisions of science, of physics rather, was astronomy.
Mm-hmm.
In what, say, 5-6 centuries ago, when they observed the motion of the stars, they had no rules or laws to predict what it would be, what the next phase of motion would be. But they developed they developed models of the motion. For example, the centripetal acceleration, v squared over r. That's derived from the measurements. In fact, it's done through calculus.
When did this occur?
I would say I'm talking about the beginnings of the astronomy.
I'm
Where they
aware, and calculus was not available at the beginnings of astronomy. It was simply geometric.
Right. I'm saying that you can derive A equals V squared over R using calculus.
Yes, but
You could
they didn't.
and I'm not claiming they did.
Okay, I thought
All
you
I'm
were saying that they were creating models.
Yeah, they created models by observing that there was a certain repetition in the motion of everything in the heavens.
Correct. Yes.
But they had nothing similar to Newton's law by which they could predict the motion of objects like comets, which were visiting the solar system, for which they had no history. And so they had no way of predicting its new path.
Yeah.
Because they had no model that
Correct.
they could apply.
I would agree. They did not have a physical understanding of what they could do, but for certain objects, such as planetary motion, they could come up with tables to predict the position of the planets, or essentially the helical risings of the planets as a function of time.
Right. But they had no laws like had, which were derivable from a Lagrangian, in which the variation of the Lagrangian predicted the Euler-Lagrange equations, for which they could then plug in the parameters that would predict the motion.
Well, I don't know if you need to do that in order. You don't need to create a equation of motion in order to describe the motion of the planets mathematically. You're right; they did not have calculus, so they could not do that. But Kepler, actually, let's start with Ptolemy. Ptolemy was able to come up with a geometric model that was predictive. Then Copernicus, then Brahe to a certain extent, and then Kepler. All of these gentlemen came up with mathematical models with no physical, or at least no real good physical understanding of why the objects were moving in the ways that they were. And in fact, Ptolemy, his justification for his position of the Earth at the center was simply philosophical. The only scientific assertion that he could make to validate a geocentric model was that there was no observed stellar parallax. But they didn't take into account that the stars could be extremely far away, which is what we see now. So just real quick, so kinematics is motion, and dynamics is what?
Oh, kinematics is the measurement of
Measurement.
motion.
Sorry. Measurement. Okay. And dynamics is
Let's play tennis.
Yes. So kinematics is measurement, and dynamics is prediction using the laws of motion as derived from the Euler-Lagrange equations.
okay. So you would you claim that is the definition that most physicists or the books that you read have made. The books I have read would not agree with those two definitions as stated. Kinematics is the equation is the description of motion, whereas dynamics is how that motion changes in the presence of forces or variable forces, energy fields, that sort of thing.
All right, let me put it another way. Kinematics is the measurement without knowing the cause of the motion. And dynamics is the prediction of future motion.
Kinematics can make predictions. If you tell me the height of a roller coaster track, you tell me the diameter of the ball that's rolling, the space and the size of the track, I could tell you where that ball is going to be sent up in the air, and then it's going to where it's going to land. I can predict using kinematic equations.
Okay, we have a horizontal wind while your ball is falling.
Okay.
Where does the ball land?
I would have to have some characterization of that wind, but that could be added to the kinematic equation as predictive.
Well, basically, it comes down to anything that's predicted based on energy principles, like the Lagrangian.
Okay.
It's dynamics.
That I would
Kinematics is
agree with.
based. Yeah. Okay. Well, kinematics is based on measurement. Yes, you can infer various equations, like the equation for free fall. You don't need the laws of physics for that. You could use Galileo's experimental techniques, and just by measurement, you could induce. That's a critical word, induction, because using dynamics, you're using deduction. You're deducing from a general principle what a particular application will do.
Okay.
Okay, so have we unified kinematics versus dynamics?
In your mind, yes. I still don't agree with your definitions, and particularly when you say that kinematics cannot be predictive. It can be.
No, no. I don't think I said that. I said that you can extract from, for example, you see the sun rising and falling in the sky,
Yeah.
and you can predict the seasonal difference after, as the ancients did, by keeping accurate records of sunsets and sunrise and the zenith of different stars and so on. Yes, they built that on the fact that there was regularity, there was a cyclic motion,
Okay.
and
I'm
and
just
then
taking this
Newton.
down to ballistic motion, a projectile. You can make that simply uses kinematic equations. You can make a prediction as to where that projectile is going to land. The only thing that you would need to know is the magnitude of the downward acceleration. That does not require any kind of physical underpinnings. You just need to recognize that there is, in fact, a downward acceleration of a certain magnitude. Once you have that, you can then begin to predict things using ballistic equations. And that
What
is
I'm
kinematics.
Yeah, and reinforce the point about uh, the use of mechanics or dynamics. If I told you that there was a sideways force, a horizontal force, while the object was falling,
Okay.
how would you include the concept of force in kinematics?
That would be an acceleration or velocity.
Well, no, I said acceleration. There's no such thing as force in kinematics, because what you measurement are only motion variables. You measure the
So,
time, the distance, the velocity, the acceleration, the jolt, and higher order derivatives.
I thought
It's
it
the
was a
only
jerk,
thing.
but I thought it
Okay.
was I thought the time derivative of acceleration was jerk. But anyway, you asked me if there was a horizontal wind. How would I
Yeah.
account for that? Correct?
I said a horizontal force. Yes.
Okay. And I would say, and my answer, I believe, was I would include that as either a accelerative term or a velocity term. Depends on how that wind is characterized.
If you have only the notion that there is a force of a certain value, certain number of pounds or newtons,
Mhm.
how are you going to translate that into an acceleration? When all you are doing is making measurements, you haven't discovered the laws of physics yet.
Correct.
The laws
So
that have been.
You are saying that I would know how many pounds? I wouldn't measure it in such a way. I would measure it as in what is the acceleration an object would feel under the influence of that wind.
How would you know that?
I would
If I
develop.
told you the force, how would I? If I gave you the
I thought
force,
there were no
how would you
forces.
know? In kinematics, there aren't. But my point is,
Yes, so
there are
therefore, why would I
forces.
characterize this in terms of force? I've said that I would characterize this in terms of acceleration and/or velocity.
I'm saying you can't do that. All I tell you is there is a sideways force of 5 pounds.
But as you've
You
said,
can't use you
you
can't use
can't
F
say
equals
there's a
ma.
force
That's
because
dynamic.
you can't say there's a force because because we don't fully have understanding of the laws of physics at this point.
That's right.
So,
Kinematics preceded dynamics.
so how
Exactly.
can you say that you have a wind, that horizontal wind, that is of a certain force when we don't know what force is at this point?
I'm not talking about a point in time. I'm talking about the development of first kinematics and then dynamics.
I understand. I think
And
we
you
are. Yeah. Sorry.
and if you're in the Middle Ages, before Newton, let's put it that way, before Newton,
Hmm.
and then there is no concept of force equals ma. Nothing that was ever published. And so
Yeah.
kinematics, I'm simply saying kinematics, the measurement and the inference of certain patterns, like the celestial motions, is what preceded the era of uh, dynamics, which we call the laws of physics.
Okay.
When the laws of physics refer to Newton's laws in mechanics and Maxwell's laws in electromagnetism.
I would also include kinematics into that as well.
No, I disagree. Because kinematics is measurement,
Okay.
not a law of physics.
I mean, I can pull any physics textbook off my shelf, and the first thing it starts with is kinematics.
Yeah,
That's good
if it
to. That's
helps,
good.
on
That's good to
the
know.
screen
But
share, I have the
Um,
definitions of kinematics and dynamics up here from Shankar's book.
Shankar.
Kinematics is the complete description of the present. It's a list of what you know about the system right now. For example, if you're talking about a piece of chalk, you will want to know where it is and how fast it's moving. Dynamics tells us why the chalk goes up, why it goes down, so on and so forth. It comes down due to the force of gravity. In kinematics, you don't ask for the reason behind anything. It simply tells you to, it's simply you want to describe things the way they are. And then dynamics tells you why that description changes with time, if that helps you guys.
So again, I don't know what the source is, but if you're trying to tell me that kinematics cannot be predictive, I strongly reject that notion. Kinematics
I'm
can
not
tell
telling you
you.
that.
Sorry. Kinematics can
I'm not.
tell you what or not where a ballistic missile is going to be at an hour later.
Just to clarify for moderation's sake, or maybe brevity's sake here, he did not say that it isn't predictive. He said it a couple times. It was a miscommunication at the beginning. The
Okay.
contention that you guys currently have is when you threw it back in with the laws of physics, whereas he's making a distinction between measurement and science, whereas science proposing the causal agent of the movement being distinct from the actual measurements in and of itself. So measurement, science, descriptive, explanatory, laws of physics being dynamics, kinematics not being included within that.
Okay. So, what I heard him say, and he can address this himself, is that kinematics are not a part of physics. Kinematics are simply measurements.
Okay, the second part, yes, but I never said that that's not part of physics.
Okay.
What is experimental physics other than taking measurements? The whole branch of physics that we called experimental physics is nothing else than taking measurements.
Okay.
And that's all. And my claim is that before Newton's time, the only thing they could do is infer from certain patterns that they saw that what the future motion would be. But
Okay.
they had no concept. For example, there is no force, no mass parameters in kinematics, because as I said, all you do is use motion variables. That's all, the only tools you have. I did
Okay.
not say that kinematics is not part of physics. It only is. It's the first part. First
Yeah. That
critical
okay.
part.
Maybe I'm misunderstanding, but I could have very much sworn that you said it wasn't. Hence my comment that I could take it down any physics book, and kinematics was the first thing that was in it. I'm pretty sure I would not have said that unless I was under the impression you were saying that kinematics was not a part of physics. But anyway,
Specifically, the laws of physics being dynamic in nature. Right. So there's miscommunication here.
Okay. So therefore, I would say, I believe my assertion was that kinematical laws are physical laws.
Yeah, I would agree with that.
Okay.
They're derived from experiment. And in dynamics, the prediction of future events is done by the deduction from physical laws, which
Okay.
are based on energy principles.
Yes.
That's what the Lagrangian is.
Yeah.
Okay, where were we? We were in the.
I just wanted to. I just
Well-
wanted to know what or get an understanding of kinematics and dynamics, so that we don't talk at cross purposes.
Right. So we were at the bucket experiment and the two different explanations proposed, and then we defined the difference between dynamics and kinematics.
Okay. Okay. The attitude or the position of Newton to explain his own anomaly was that there is an absolute frame of reference in which is independent of the physical world, and relative to which, when the bucket rotates, there is a centrifugal force, and when the bucket does not rotate with respect to this quote absolute reference frame, and there's no centrifugal force. The problem with this is he doesn't identify in the real world where we take measurements, where in the world is this absolute reference frame. So he leaves it in an immaterial sense. He doesn't connect his absolute frame of reference to the physical world.
Okay.
Okay,
Yeah.
that's the statement that that's the explanation for Newton. And my consideration for that is he doesn't identify where we should place an observer in order to take measurements and to establish this absolute reference frame. We do know that Newton in the lab frame, that is in the Earth-centered, Earth-fixed frame, in which the Earth neither rotates nor orbits, but is at rest, absolute rest. We know that that's a correct interpretation of the experiment, because when the bucket rotates with respect to the laboratory, there is a prediction that there will be a vortex. And when the water does not rotate with respect to the bucket, this agrees with experiment.
Why are you gay?
So we could say that we've identified the Earth as the absolute reference frame because it satisfies Newton's definition, plus it does allow us to place an observer and test it. And that's exactly what Newton did.
You are, I believe, I would say that you are asserting that without evidence, that you are stating that the Earth is in fact a moving or is a stationary, non-rotating frame, which is not the consensus. And I believe that has been proven experimentally.
Well, I'm just showing you that Newton's bucket shows that the Earth is not rotating. If it were, then the application of Newton to a bucket in which the water surface, in which the water was not moving, would show a vortex. And that's not what is observed.
You'll have to forgive me. I'm not quite following your logic. So we observe a vortex outside the bucket because the bucket is no longer an inertial frame. The
No.
laws of physics, Newton's laws or Newton's equations of motion require augmentation in order to fully describe what the water is doing. And that is the introduction of an emergent force known as a centrifugal force. So
No.
how does that tell us that the Earth is in fact an inertial frame?
Well, what is the definition of an inertial frame?
An
It's a
inertial
frame
frame.
in which.
Sorry, go ahead.
All right, go ahead.
Oh, inertial frame is a frame in which the object is not accelerating, or the frame is not accelerating.
And how do you know it's not accelerating?
Well, that's by definition.
Well, then it's not testable, is it? It's a definition. Do we agree on the scientific method?
I believe I would think we would agree on the scientific method. Yes.
Yeah. So if we use the scientific method to verify our experiments, and we see that if the Earth were the absolute reference frame of Newton, then when the bucket was spinning with respect to the Earth, it would you could apply the laws of motion to it, the centrifugal force law. You would see
you would see it. You would have to apply the the emergent forces due to the fact that the bucket is now is not an inertial frame. I don't see how that informs you as to whether or not the observer themselves is in an inertial frame.
Well, Newton is in the lab. He's at rest. So Newton.
How does he prove that?
What? How does he prove he's at?
Correct. How does he prove that that the Earth is in fact stationary and non-rotating?
Oh, Newton is at rest with respect to the Earth.
Correct.
That's what I'm saying.
Okay. So
All right.
how does he? So again, how does he know that that his frame is inertial?
Because an inertial frame is one in which the laws of physics are valid.
His three laws of motion are valid without emergent forces. Correct. Yes.
My statement is the laws of physics are valid if you are in the Earth's reference frame, the lab frame.
Okay.
And the proof of that is the bucket experiment.
So physics would tell us that the three laws of Newton's laws are valid in inertial frames. It does not state that the Earth is in fact an inertial frame, and in fact it's not, for a couple of different reasons.
Such as?
One, it's rotating. Two, it's revolving.
Wait.
Three,
how do you know
it's in a gravitational field.
All right. How do you know it's rotating?
We can see its motion with respect to we can see its motion with respect to other objects. We can also measure we can also see its we can measure its rate of rotation. Yeah.
All right. So that's kinematics, not dynamics. Newton's laws are laws of physics, and they are applied in dynamics, not in kinematics. Now, if you say the Earth is rotating because you see it rotating with respect to other objects, that's just the law of relative motion, and that only applies in kinematics, not in dynamics.
I think that
So
is a fundamental problem, is that you are just basically stating that you are saying that because we are measuring the relative motion between two objects, this falls within the realm of kinematics and therefore cannot be does not describe a physical process, or Newton's laws are not in play here. Like, this is where I'm very confused.
yeah, I'm confused too, because you said it's not a physical process. No, I didn't say measurement is not part of physical measurement or process. What I'm saying is that there are two distinct branches of physics, one in which you take measurements and the other one in which you make future predictions. When you take measurements, you are not predicting the future, you are measuring status of the
So
environment
again, with
as it is now.
kinematics makes predictions.
Only if you infer from previous experiments what the basic pattern is. You do not use principles of energy conservation. You do not use F equals ma. You don't use any of the laws of dynamics to
Okay.
make predictions.
Okay. You don't use any of the laws of dynamics to make predictions. That's correct. Yes, kinematics does not use. On the face of that, I would say that is correct. You do not use the law, or you do not use dynamics to make predictions using kinematic equations. Correct.
Okay, I agree.
So how is it that you are discounting measurable relative motion between two objects as not being, I guess, physical, or I don't know, worthy of consideration? I'm
No,
confused.
not part of dynamics.
Okay.
The law of relative motion. An object A observes that there is motion with object B.
Correct.
Then object B will observe the equal but opposite motion of object A,
Yes.
or of relative motion. Okay? That does not apply in dynamics because of Newton's bucket, which we've just discussed.
All right. So my question then is, we see the Earth's motion change. We see a motion between of the Earth with respect to other objects, and we see that motion change with respect to other objects. So, regardless if it's kinematics or dynamics or not, how is it that you are defining that the Earth itself is stationary, whereas the other objects are in motion?
Because of Newton's bucket. If
You,
Newton
you,
makes measurements from his lab frame,
which you are
gee,
asserting is a rest frame, which you cannot assert. Newton cannot absolutely state that he is in a inertial frame.
all right, we don't understand reference frames. That's obvious. Wherever the observer is
I would ask that you
at
not
rest.
make statements about what I do and do not understand, and I will do the same for you.
What I said was that we do not have an agreement understanding what reference frames are.
Okay.
All right?
We do not have. Yes, that's correct. Well, I don't know about that. What you are saying is that because of Newton's bucket, that Newton himself is in the lab frame, in the rest frame. But that's not what that experiment tells you. All that experiment tells you is that the bucket itself is rotating, is accelerating relative to Newton's frame. It does not inform you at all as to whether Newton's frame itself is in fact accelerating.
Wherever the observer is by definition the origin of his reference frame. An observer cannot be in motion in his own reference frame. I'm sitting at a desk now to the Earth at rest. So the Earth's lab frame same as my frame, because I have no motion with respect to that. So,
So you-
Newton, in his lab frame, observing the bucket, he considers himself at rest. Bucketeer, from his point of view, considers the bucket is at rest and that Newton is rotating along with the lad around him with the opposite spin that Newton sees.
yes.
So unless we have that clear, that distinction, that an observer is at rest in his own reference frame, and
That is,
and
yes, we understand that perfectly. Like, Newton is at rest within his own reference frame. What is not clear is that I am stating the reference frame itself is not inertial. The reference frame itself and everything within that frame are accelerating.
the inertial frame, by definition, is one in which the laws of physics are observed, are valid.
The inertial
We know
frame
that-
is where the three laws of motion defined by Newton are exact. You can't, if your frame is accelerating, then you have to deal with emergent forces such as centrifugal or Coriolis.
How did Newton define the inertial frame?
I believe in the same way that we define inertial frame. Inertial frame is one that is either at rest or at constant velocity.
No, he defined it in response to his own problem with Newton's bucket. Namely, he defined the inertial frame as one in which the laws of physics are valid, and he proved that the Earth is reference frame, the lab, is a valid inertial frame because the laws of physics applied to the bucket that are in the bucket accurately predict what will happen. On the
So,
contrary, the bucket observer, when looking at the water, which is stationary because it's co-rotating with the bucket when viewed in the lab frame, they predict, or the bucketeer predicts, that the water will be surface will be flat, be no centrifugal force, which is contrary to observation. So the laws of physics are not obeyed in the bucket frame. So they are in the lab frame, they're not in the bucket frame. Now we can project that onto the entire universe because
okay,
does the bucket have to be? Where
I
does
just
the
want to,
bucket have to be?
go ahead. Go ahead.
Try to let Son finish.
Go ahead, Dr. Bennett.
Okay, if we extend the bucket and ask certain questions about its position in the universe, we find that any rotating object relative to the lab frame will not obey Newton's law. For example, if I ask, where does the bucket have to be in order for the centrifugal force law to be applied? Well, the parameters are the mass, the rim speed rotation, and the, well, it depends which you take. The angular velocity and the radius is one choice, or you could use the rim speed and the radius. Either one, since they're interchangeable. All right, if you use that law, you can apply it at any distance from the Earth. So no matter where the bucket is in the universe, Newton's laws will predict that if the observer is on Earth in the lab frame, the laws of physics will be accurately predicted. But if the observer is on a rotating object, doesn't have to be a bucket, could be anything that's rotating relative to the Earth, that the laws of physics will not be obeyed. Our conclusion is that if we extend the observation that Newton made in his own lab and moved the bucket throughout the universe, the same observation will be made. Bucket observer will not observe correctly, will not apply laws of physics successfully. In that case, then we can say that anything that rotates relative to the Earth is not in the lab frame because it's in relative motion. And anything, therefore, rotating with respect to the Earth is a non-inertial frame. It does not obey the laws of physics. And so that's the projection of the absolute lab frame. And if we discussed Ernst Mach said, yes, the Earth and the rest of the universe contributes to the lack of validity of the laws of physics. But the rest of the universe is in motion relative to the Earth. Everything in the sky is in motion relative to the Earth. So
Okay.
it's all everything is like a rotating bucket.
Okay.
Therefore,
Again, and I don't know if we can get through get past this, but because you continue to simply assert this without addressing it, is that I don't care what Newton had to say. What classical mechanics states is that when you look at a rotating object, when you have a frame that is it is accelerating in some way, then the three laws as written do not apply. You have an emergent force coming in. That's all that you can say. When it comes to the observer outside, that does not inform you as to what your frame is doing relative to that. We assume within experiments done on the Earth, we assume that the non-inertial corrections that need to be made because of our motion and because of the fact that we are in a gravitational field are negligible in terms of the precision of our instruments. It is not simply asserted that it is, in fact, a rest frame. Like it is in the sense that it is completely at rest. It is defined as inertial. Physics does not state that the Earth is, in fact, a inertial frame by definition. Because if you were to do experiments just simply on the Earth, if you were to roll a ball on the Earth straight for a really long time, that ball would not be described strictly by Newton's three laws of motion. You would have to include a Coriolis effect with that, or Coriolis effect. This is demonstrable in terms of hurricanes and typhoons.
okay, so that is your assertion.
Okay.
You have no evidence.
Okay. Well, I mean, I have the evidence of hurricanes and typhoons that are described by Coriolis effect. But can I ask you another question?
No, because I have a response to what you just said.
Okay.
You said that I make assertions without evidence. Well, I've been describing for, I don't know, the last half hour, Newton's bucket, in which you could repeat for yourself and observe that if you are at rest in the Earth frame and apply the laws of physics to the rotating bucket, where the water is co-rotating with the bucket, you will correctly predict that a vortex will be formed by applying centrifugal force. You can also verify that if you were on the bucket observing the rotation of the Earth, which is kinematics, and then apply the laws of dynamics, centrifugal force law, you would find that applied to the water, it does not predict that a vortex would be formed. So you claim that I'm making assertions, but I'm just claiming to repeat visual evidence which Newton observed over 300 years ago and can be easily repeated in any laboratory. So I'm not making assertions without evidence. Newton's bucket is something that has challenged 3 centuries or more of physicists in order to try and explain. And my explanation is basically a combination of Mach's principle, which says that the Earth and the rest of the universe causes it. I say just the Earth is what's needed. An absolute reference frame of Newton, I claim, is the Earth, the ECEF, Earth-centered, Earth-fixed frame.
Yes.
And the evidence I can give is many more experiments, not just Newton's law, not just the centrifugal force law.
So let me rephrase this, I suppose. If you were, no, I don't know how I would rephrase it in that context. I understand the bucket, the bucket, your bucket example or bucket experiment, but you continue to state that the
Who is that? Okay. I got
Guilty.
it.
That's good.
you continue to state that the observer outside of the frame is in a rest frame. What I am saying is that they can be treated as if they are in a rest frame based on the imprecision of measuring instruments. The alteration of the amount of centrifugal force, for example, or Coriolis force that needs to be applied within a lab room is very, very small. But if you had an instrument precise enough and you wanted to very, very precisely describe the motion of anything, you would need to account for the fact that the Earth is not a inertial frame. I have given the example of hurricanes as an example of that. Is that wind, as it is moving in a straight line, is going to be deflected by the centrifugal force it experiences as the Earth rotates.
And what if I claim that the observed so-called Coriolis force is just an indication of the ether rotation around the Earth, which other experiments have shown to be indicators of the ether wind, such as the Foucault pendulum. That
Okay.
can be explained as an ether wind which surrounds the Earth with maximum speed at the equator and 0 at the poles.
Yeah.
And that ether wind can also explain the observed weather patterns, high and lows. Well, this is actually getting away from Newton's bucket, but perhaps that's best because there seems to be an impasse in understanding. If the Earth were rotating from west to east, eastward, and we would see the sun rising in the east. Is that correct?
Correct.
Okay. The winds that surround the Earth, if the Earth is rotating from east to west, relative to the Earth, which way should we see them blow?
The opposite direction.
We should see them go in the opposite direction. So in the mid-zone of the Earth, we should see the predominant winds are westward. The predominant flow of weather systems should be westward. Is that what we observe, Dr. Parks?
No.
No.
Oh, at the pole. Did you say at the poles?
No, no.
Oh,
At
I'm
the
sorry.
mid latitudes.
Mid latitudes. I believe that is correct, yeah.
Well, is that what we observe? Do weather systems move across the United States from east to west or from west to east?
West to east, I think.
Yeah. And yet you said that if the Earth rotates, the air should move. And I agree with that. If the Earth did rotate, the air should move from east to west. There should be a westward wind, Doctor, but there
Yeah.
isn't. It's in the opposite direction. How can we explain that? By an ether wind, it's moving around a stationary Earth, and that is moving eastward.
So,
That explains the weather patterns.
are you
It's a
familiar with
rotating Earth. That's not.
Are you familiar with the concept of Hadley cells?
Yes.
Okay. So, Hadley cells, which explain the directions of the mid latitude, low latitude, and upper latitude, are driven by Coriolis. If we were not rotating, then we would have no Hadley cells at all. But because we are rotating at the rate that we see that, roughly speaking, we have 6 cells, 3 in the north, 3 in the south. If you look at if you look at Jupiter, which is rotating significantly faster, you can see that there are significantly more Hadley cells. The bands moving in one direction versus the zones moving in the other direction. This is also seen on Saturn. When we look at on Venus, which basically is extremely slow in its rotation, we don't see these Hadley cells. So is ether wind also driving weather patterns on other planets?
Could be, but you haven't answered my question. First question I posed was, if the rotation of the Earth would cause the surface air to move westward,
Mhm.
why do we find the weather patterns moving eastward?
Oh, so the Earth is rotating, let's see, west to east,
Eastward.
eastward. Well, they are moving eastward they are moving, so the Earth is rotating west to east, and so the sun appears to go east to west. The reason why the winds are going from west to east in the mid-latitudes is because they are being forced in that direction by the Coriolis effect in between the upper latitudes and the lower latitudes. How does an ether wind explain the alternating direction of wind currents? Because Coriolis explains it.
You said the Coriolis force explained the Hadley cells, which are
Yeah.
rotational cells.
Which are
Okay, they go for a certain distance eastward, then they go south, then they go westward, and then they go north. They create a circulation pattern.
Yes, an overall general circulation pattern where the winds in the upper latitudes move contrary to the winds in the mid latitudes, which move contrary to the winds in the low latitudes.
Are you familiar with the jet streams?
I am, to a certain extent.
Which way do the jet streams move? There are 4 of them.
I'm not sure.
You're not sure? Well, if you watch the weather forecast like my wife does every night, you would know that they always show the jet stream coming in off the Pacific Ocean, going across the boundary between Canada and the US, and then exiting on the East Coast.
Correct.
So that would mean, so that means that it is an eastward wind.
I'm not challenging that. What I'm saying.
I'm asking for an explanation, because in a rotating Earth, which is your model, the Earth would be dragged because of inertia. It would lag behind the rotation of the Earth. It's not rigid, it's a gas. So it would trail behind, just like smoke would behind a car moving, let's say, north. the smoke trail behind it would be headed south.
That's assuming that
Because-
that's assuming that the atmosphere itself does not have an inertia of itself, which is co-rotating with the Earth to a generalized way. But again, I have given you an explanation as to why the winds are moving from west to east in the mid-latitudes. I only know of one jet stream, and I know that or I'm pretty sure that one moves also from west to east. But it does so because of the Coriolis effect, because the winds above the mid-latitudes move from west or east to west, and the equatorial regions, generally speaking, also move from east to west.
Okay, the Coriolis effect depends on the direction of the wind and the what else? The radius of rotation. In any event,
And speed.
Coriolis effect produces these circulating cells. The jet stream and the motion of weather systems is not a circular pattern. To predict the Coriolis force would predict low and high pressure systems, for example, in the weather. That is not what we see with the jet stream. It is a linear circular motion,
Ish.
always in an eastward direction. Yes, it moves up and down in latitude, but basically the four of them are fixed about an average latitude. The point
It
is
is
that
also
if you can't
kinky.
explain the paradox of the contradiction of having a rotating Earth rotating eastward, predicting that the air that we observe from the surface would be seen moving westward, it's opposite to what we actually observe. This is what we would call a showstopper. If you can't explain that.
I believe I have explained that a couple of different times. As for the jet stream, I believe the jet stream is a relatively localized event, and I believe that the cause for the jet stream itself goes beyond just simply the rotation of the Earth. There are other factors involved that I don't know about because I am not a climatologist. There are generalized circular patterns caused by the rotation of the Earth, known as Hadley cells, and for the Earth, in the way that it's rotating, the winds at the mid-latitudes go from west to east. In the northern latitudes, they go from west or east to west, and also in the equatorial region from east to west. I don't know what more of an explanation you want me to provide. I'm not denying that the wind system goes from west to east. I am telling you my explanation for that is because of the cells, the wind circulation cells that are produced by rotation.
All right, if the rotation of the Earth were to cause the motion of the air in the direction that we've indicated, that it should be contrary to the rotation of the Earth, that is, move westward, you cannot explain using the Coriolis force, because you use that to explain the Hadley cells, which are localized areas of rotation.
Hadley cells are not localized. There are global Hadley cells.
Really?
I don't know how many times I can say this, but winds at the mid-latitudes move from, generally speaking, from west to east. In the northern latitudes, they move from east to west. Also, they move from east to west in the equatorial region.
Hadley cells include vertical motions, up and down.
Correct. They also include left to right.
and they are localized.
There could be localized cells based on local conditions, but the overall Hadley cells are caused by rotation, which is why we see the same effect on Jupiter, we see the same effect on Saturn, and to a sort of contrary extent, we see the same effect on Venus.
All right, suppose you have air moving north from the equator.
Yeah.
How does the Coriolis effect change that to an eastward wind that we see with the
I believe it deflects. If it's moving northward, it will deflect to the right.
right. Now it's moving eastward.
Okay.
And what happens then? It's deflected southward.
And in a local, for the local environment, that is correct. Yes.
Okay. So how does that explain the jet stream, which does nothing like that? It circulates around a particular latitude.
As I've stated, I am not certain what are the specific causes of the jet stream, but I believe they have to do with other factors beyond the rotation of the Earth. Because the jet stream is variable in its
what are those?
Is variable in its path and also variable in its location.
What are the other factors?
I'm not certain because I am not a climatologist. I would assume it has to do with the atmosphere or the temperature of the atmosphere at that point, the pressure of the atmosphere at that location, probably the density of the atmosphere. Can I ask you another, moving on to a different topic, can I ask you another question?
Let's go.
All right. So, how old is, or excuse me, has the Earth always been here?
We talking science or theology?
We're talking science. I always talk science unless I'm having a theological discussion.
Okay. Well, scientific history goes back at best 4,000 years. So
no, I'm also not talking about history.
Okay. What are you talking about?
What is the age of the Earth? From a geologic standpoint, what is the age of the Earth?
The age of the Earth is undetermined.
Okay.
The only date that I can put is the historical record of what has been passed down, and that's approximately 4,000 years, maybe 5,000.
Okay. So you believe that the Earth is 4,000 years old, maybe 5,000.
I say that it is provable that it is that age. Yes.
So provable. Okay. Then why?
Not by experiments today.
Okay.
Not by experiments today, but by the historical record.
Which historical record are you referring to?
All of the history of the Egyptians, the Greeks,
The
Jews.
From my understanding, the mid-kingdom of Egypt was around 4 or 5,000 BCE, which would actually place the Earth as older as 7,000 years old at the very least.
What scientific history did they provide that would allow us to accurately date them?
I am asking. You are saying that you can prove it via historical record.
Yeah.
So I would like to know what historical records you were using, and how do you know that those are in fact accurate?
Well, I know that Eratosthenes measured the radius of the Earth. I
Right.
don't know exactly what that date was. But that's been repeated many times, and that indicates that that was an authentic uh, experiment.
Okay.
There are other observations of the heavens, like eclipses and so on, which we know from our own modern astronomy. We
Yeah.
can date those, and we can project that those eclipses that they saw occurred on a certain date, that is within a certain year, let's say. So that's
We
what I
can
mean
make
by
estimates of that.
scientific
Yeah.
history.
Okay.
So yeah, so I'm saying that's the scientific history that I believe is credible.
And so so what would be the record which indicates the time equals 0?
I don't know the exact date. All I know is an approximate date for the beginning of the Earth.
So I guess my question then is, what part of the historical record gives you the estimate of 4,000 to 5,000?
Oh, the records we have of the Egyptians building pyramids that accurately indicate directions relative to the cosmos, aligned with certain stars.
If you're talking about
Um,
the Orion Nebula, that's been debunked, or Orion's belt, that's been debunked.
no, I don't. I'm not referring to any particular one. I'm going strictly from my vague memory of
Okay.
what the history, what the scientific history has been.
My apologies. So that gets us back to, so are you saying that the Egyptians are the first civilization? Like, I asked you specifically, how is it that you know that the universe provably, you said provably, that the universe or that
Yep,
the Earth is 4 to 5,000 years old?
from scientific history, from the
What specific
historical.
scientific history?
I can't point to a specific one because
Okay.
I don't know the dates offhand.
Okay. Fair. Um, so the
You know,
universe,
if you had indicated that this would be an issue, then
no,
I could have
no, I'm not debating you.
dived in.
I was just curious if you knew. If you don't know off the top of your head, that's perfectly acceptable.
Would you like to tell us the relevance of the discussion?
Um, ultimately, the relevance is if he believes that the universe is 4,000. I was trying to figure out how old he thought the universe was, because my question would be, if he believed the universe was very, very old, then my next question would have been, what was before the Earth? But it seems as if the answer to that question was there is nothing before the Earth. Would that be an accurate statement, Dr. Bennett?
Yeah, there's nothing I can prove that is uh, acceptable logically to say that there was anything before about 4,000 years ago.
Okay. So, and pardon me if I don't mean to misrepresent you or ask you to explain things you don't know, but do you believe that the Earth was created alongside the rest of the universe, or was the Earth created sometime after the universe itself was created?
Well, now we're getting into theology. I
We
mean,
are not.
pretty clearly, these are not scientific, um, e- scientific method acceptable. What
Okay.
are these questions falsifiable?
So you are basically claiming that the entirety of astronomy is um, not scientific.
No, I didn't say that. I said I can't.
Astronomy
can't
tells us
prove
that the astronomy tells us that the sun is 4.55 billion years old.
Okay, how do you know that?
Two ways that come off the top of my head. We know that at the very least, the debris from the protoplanetary disk is roughly about 4.55 billion years old due to radiometric dating of meteorite samples. We also know that, or we also have evidence that supports this using the model of nuclear fusion as a function to create energy in the sun. So based on the sun's current luminosity, temperature, so forth, the sun would need to be 4.55 billion years old.
Okay, how do you know the debris is 4.5 billion years old?
Radiometric dating.
Radiometric dating, is
Yes.
that using rocks or is that using radiocarbon dating?
It is not using carbon, it is using uranium specifically.
Okay, how do you know that the uranium has been decaying in all of the past years and was deposited in an original state in which there was no radiation present?
I'm sorry, you cut out. I don't know if you were continuing that
No,
line of thought or
no,
not.
that's a question. How do you know that the uh, radio radiometric dating of rocks, that is uranium specifically, how do you know that the deposits of uranium had originally no radiation? They were pure uranium. They didn't have daughters products mixed in with the parents. How do you know that? And how do you know it didn't change in all of the thousands of years that it allegedly decayed?
So, are you, are you saying how do we know that the decay rate doesn't change as a function of time?
No, I
Okay.
didn't say that.
All right. Okay.
What I said was, how do you know that the deposit of uranium that you're testing originally started with pure uranium and none of the daughter products that arise from the decay?
Mhm.
Or at the sample that you're testing was not uh, influenced by physical means, that is, the amount of rate of uranium in the sample could have been washed away, eroded, which would lead you to include that there's missing uranium and therefore it's decayed. All of these point to a lack of provenance. Provenance means you have no record of what actually happened to the uranium during the alleged decay process. You don't have any secondary proof that the uranium was undisturbed in the sample. Familiar with Mount St. Helens,
I
which
am familiar.
erupted in 1980,
Mhm.
which is
I was 4.
what, 1984. All right,
No,
so
no, I
it's
was.
40
If it
years.
was an 80, my age was 4. I was 4 years old, but I still remember it.
Okay, well, I remember it, and I wasn't 4 years old. the 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 rocks that were deposited after the eruption of Mount St. Helens were tested, and the radiometric dating that was applied to those rocks indicated that they were anywhere between 1 million and 3.5 million years old.
Mhm.
Now, the rocks were formed by observation in 1980. And so we have a modern proof or a disproof that the theory of radiometric dating very much flawed, because even with modern dates, it cannot accurately predict the dates. It asserts that there is millions of years of decay, when we know, in fact, that since the rock was created is only about 40 years.
What do you mean by the rock was created? I'm not clear I know what you mean by that.
I mean that the uranium, if any, that is found in the samples was created from other materials in the intense heat in the volcano, and that when that cooled, the uranium then began to decay
Okay.
because it was then formed.
So you're saying the uranium was created in the eruption.
Yeah.
I didn't realize that volcanic eruptions were quite that powerful.
Well, that is the I guess the consensus of
That the
geologists.
temperature of a volcanic eruption is large enough to take lighter elements and then create uranium from it.
Or bring them up from the depths up to the surface. Yeah.
But if they were from the depths, that would still be a part of the Earth.
Yeah, but at a much higher temperature.
But it would still be uranium coming up from the bottom, which would be still part of the Earth, and so therefore the age, as dictated by those measurements, would be the age of that part of the Earth.
Okay.
And what I'm talking about is not that. I'm talking about meteorites. Now, you had asked basically the initial fractions. I think what you're asking is that the initial fractions of uranium and the daughter element, whose name who escapes me at this point. I'm not certain.
The end
I'm not
product is lead.
lead. Okay.
The end product, all
I'm not.
uranium chains
Sorry.
end in lead.
Okay. I'm not. I am not certain because, again, I'm not a planetary geologist. I'm not certain what those assumptions or how they determine that. But when it comes to interference, when it comes to adding things into it, my question would be then how would elements be added to the rock, the meteorite, to skew that event, or to skew that measurement? What physical phenomenon would do that?
I'm talking about the erosion, as I mentioned. The erosion that occurs where you have let's say 10 grams of uranium, and then you have separation of that sample into different parts by erosion, by
Erosion from
oceans
what?
from water in the subsurface of the earth.
I'm talking
There is
about
water
meteorite.
underneath.
I'm talking about
Yeah, well,
meteorites.
all right. Well, I'm talking about the radiometric dating of um, samples taken from the Earth's surface.
You asked me how I determined that the Earth was, or the Sun was 4.5 billion years old. My example,
Right.
or one of my pieces of evidence, were meteorites that fell to the Earth, that those samples are measured to be approximately 4.5-ish, 4.5 something billion years old. Well, 4.55. They do not come from under the Earth. They are not found under the Earth. They are found on the surface, primarily in Antarctica, as it ironically happens. So I'm wondering what in that process causes the erosion of uranium or whatever, whichever elements you're talking about.
All right. Any radioactive species that's present in a meteorite has a certain is a certain amount present.
Correct.
In order to determine what the half-life is, you have to wait for a significant amount of time. You don't have to work. You don't have to wait for it to decay to half of its original sample size.
Yeah.
But the decay of the sample is influenced by the amount of uranium that was originally present compared to the amount of daughter that is present. And that's the way they estimate the age that it's been decaying.
Okay.
But if that ratio of parent to daughter has been disturbed by physical processes, and I was talking about within the Earth, but how can you explain what happens in the depths of space? The original uranium can
Exactly.
be
You
subject.
are asserting that there is erosion happening, or erosion may be happening. And my question to you is, what is causing the erosion of meteorites as they fall to the Earth?
Well, suppose we have a sample that has 10 grams of the uranium and 5 grams of the daughter. And we use that to estimate the age of the meteorite. If the sample was 10 grams and had the daughter product increased, not by decay, but by the physical fusion of the uranium sample with this extra content of daughter, then the interpretation of the age of the meteorite would be incorrect, because in the process of moving through space, the mixture of the elements, parents and daughter, was changed not by decay but by physical processes.
And
So the
I'm
basic
asking you, what is that physical process?
um, I don't know what happens in space,
Okay.
and I don't think you do either, because neither of us have been in space.
I don't need to be in space in order to study it.
But you only know observe through the telescope, not what you have from first-hand, upfront knowledge. And
Okay.
that's a difference. How do we know what the starlight is? It's assumed to be similar to the sun, and yet there are many differences in the spectrum of the stars compared to the sun. But we get into a different topic.
Well,
So
again, okay.
suppose two meteorites collided, and one had uh, an amount of daughter product that fused with the sample of uranium, thus making the age calculation totally uh, totally wrong, because the parent to
Then
daughter combination is what. Yeah, I know you're going to ask what causes the collision of meteorites, right?
no, that's not what I was going to ask.
Um,
I know what
well,
causes the collision of meteorites.
you're asking me
I'm
what
sorry to
happens in
interrupt, but this is
space.
kind of heavily detracted from the conversation of heliocentrism versus geocentrism. We're getting into trying to date the universe. That's kind of retarded. We can't do that. One believes you can, the other believes you can't. Do you have any mutually exclusive evidence to support why you believe that the Earth is in motion? Your
Yeah.
model is the correct interpretation?
Yeah, or like, does someone? My have the vote is the same. If someone maybe wants to present a piece of evidence in support of either or position, that the Earth is moving around the sun, for example, or that the Earth is stationary. Because you can debate the alleged age of Earth or radiometric dating for 2 hours in and of itself, right? I don't even see the relevance of it anyway. Say the Earth is 50 billion years old, it could still be stationary.
The
So-
relevance comes into, and I apologize. So this was a discussion about or basically cosmology, whether or not the sun or the Earth is the center of the solar system or potentially universe. I actually don't know if I'm assuming that Dr. Bennett, he believes that the Earth is the center of the universe. I do not believe that the sun is the center of the universe. So I've always had a contention of this label of heliocentrism, because all that states is that the sun is the center of the solar system. But ultimately, it's a discussion about cosmology. I'm not attempting to debate here. I'm asking questions to get an understanding of why it is that why does he support the position that he does. And in terms of aging, I'm a little, I don't think it's quote unquote retarded, because we do have supporting evidence that is that the universe is significantly older than 4,000 years. But this isn't a debate. I'm not. If you'd like me to give you examples, I can certainly give you the examples. But ultimately, what it comes down to is, from a cosmological question, is how did the universe come into being? And that would then dictate why the Earth itself is a preferred position within that universe. That's ultimately what I'm trying to get to, is why is the Earth the preferred point in space? We've already talked about rotation, in that he has already said that there is relative motion between two objects. So far, he has not given me a very good or compelling argument as to why the Earth must be stationary. He keeps referring to the Newton's bucket, but I keep telling him that that does not say that the frame in which the bucket is located, or the rotating frame of the bucket that is surrounded by the observer's frame, that does not state that the observer's frame is in fact inertial. So,
Okay, Bennett, you want to respond to any of that, or give the reasons why you hold the position that the Earth is stationary?
Yeah. Well, the original point in which I started evaluating the role of the Earth was the Newton's bucket experiment and the history of what different people had thought about it. And I asked the question, if we are on a if we have a reference frame in which the laws of physics are obeyed, in any other reference frame, that is, any other observer moving relative to the Earth, does not apply the laws of physics, and the Earth is by definition an inertial frame, which is what Newton called it. He called any frame like the Earth that obeys the laws of physics is an inertial frame. And so the bucket, according to his experiment, would be a non-inertial frame. And that's the way I came into the conviction, by using other experiments like the hitchhiker on the surface of the Earth and various energy conservation violations. They all point to an Earth being stationary in dynamics. What that means is the Earth is the only inertial frame. When physicists say, consider an inertial frame moving relative to another inertial frame, immediately there's a contradiction. because inertial frames, according to the bucket experiment itself, cannot be in relative motion and yet both obey the laws of physics. Only the Earth, according to the scientific method requires, that is, direct visual evidence, shows that the bucket is just one of many experiments that shows that the Earth is a preferred frame in the sense that the laws of physics must be applied in that frame. And that's a review of the Newton's bucket. Yeah, the relevance of Newton's bucket.
Yes, and as I stated, I understand the concept of Newton's bucket. And as I've also stated, you said by definition, the Earth must be an inertial frame. That is not in evidence. And again, I have said that the Earth can be taken as an inertial frame due to the crudeness of our everyday measurements. But if you truly wanted to describe an object down to, nanometer per second precision or something of that nature, then you will have to take into account the fact that the Earth is in fact not an inertial frame. So, and again, you keep going back to Newton. I'm talking about classical mechanics because Newton was a phenomenal individual, brilliant man. But his ideas have since matured through the ages. And so I am simply referring to what classical mechanics is saying. And the idea that and again, I could be wrong, but I think I just heard you say that two inertial reference frames is moving relative to each other at a constant velocity is a contradiction in physics. It's not. There are no physical laws that state that two frames that are moving are either at rest relative to each other or are moving relative to each other at a constant speed, how that is somehow impossible. The issue with Newton's bucket is not that it is moving. The issue with Newton's bucket is that it's accelerating. Therefore, that is why it is not an inertial frame. And that is why the Newton's laws of motion are not applicable straight on. That is why emergent forces come into play.
Well, I don't see that we can really go any place further because you stated that I say by definition that the Earth is an inertial frame. That is incorrect. I say that by the scientific method, that is by an experiment like Newton's bucket, I show that in the Earth's frame, the laws of physics are obeyed. In any other moving frame relative to the Earth, they're not. I don't make a definition, I make an observation. And the observation is that I see that an inertial frame can only be identified with the Earth.
Is it an
I'm using
observation
the
or a
science.
measurement? Is it an observation or a measurement?
They're both the same.
No,
Talking about a prediction.
They aren't the same, but
We're making. I tried to make the distinction between kinematics and dynamics. Newton's laws predict the future. A measurement of the state of the bucket is kinematics. That's a measurement of what the bucket is doing. A prediction of what the bucket would do in the future, that is what the water would do in the rotating bucket in the future, is an application of dynamics because no measurement is taken. So the application of theory is dynamics. And that's where the inertial frame is relevant. There is no definition that's relevant in kinematics because when you make measurements, you're not testing the law of physics. You're just making a measurement.
In kinematics, you are not testing the laws of physics. That is what you are. Is that your statement?
Yes, the kinematics is purely measurement, and you can take measurements that either are used to predict or validate a theory or to generate a new theory.
So if I were to use the laws of kinematics to predict how far a hockey puck would slide across a hockey rink, I would not be describing physics.
That's a strange definition.
That's your definition, sir. You said
No,
you cannot use the laws of kinematics to describe physics.
No, I said the laws of kinematics, measurements define kinematics. So all you can use in kinematics is a clock and a ruler. So you are measuring instruments for kinematics.
Yeah.
If you want to predict the future, then you have to use the law of physics, which started with Newton and was developed to the extent that all of the laws of physics can be shown to be derivable from an energy principle called the Lagrangian, which results in the Euler-Lagrange equations. So I'm defining dynamics as predictions based on the Euler-Lagrange equations.
That is an equation of motion. Yes, I'm aware.
Yes. Yes.
So what I'm talking about is making a prediction based on kinematic laws, and that's it. All I have are kinematic laws. That's all Galileo had. So if I make a prediction of the motion of an object strictly using kinematic laws, kinematic equations, what is that? Is that physics?
That's an induction from the measurements,
So
which indicated a pattern, such as you see in astronomy when you see the cyclic motion of the objects in the sky. You can deduce from that there is a repetitive motion that's being observed, and you can use that to predict the future. Yes, but I'm defining the dynamics as I just did, as
I
any
know.
laws. All right.
Yeah, I understand. I understand. I just don't understand the relevance, what this has to do with inertial frames.
Well, the laws of physics, as defined in dynamics, are solutions to the Euler-Lagrange equation. And the centrifugal force law is one of many examples of the Euler-Lagrange equations,
So
where they were generated by the variational principle applied to the Lagrangian.
yes,
And that's not true. That's not true for kinematics. Kinematics is simply the measurement and induction of patterns that are seen in a set of measurements, in a set of data that indicates that you can new laws from that.
the laws of kinematics began that way. Yes, like I said, with Galileo, and then Newton through what's the word I'm looking for? Underpinning to it. He explained why those patterns existed, and his explanation was gravity. And so you can solve the Euler equation. You can do the Lagrangian on a system that is non-rotating, and you can get the kinematic equations from that. So the solving the Euler equations or doing the Lagrangian does not give you just simply the the centrifugal force, and that's it. Depending on how you define the energy in your system, that is going to define your equation of motion. If the energy in the system involves a rotational energy, then you are going to find that you have centrifugal force in that equation. If it doesn't, then that force will not be present. As defined through classical mechanics, again, an inertial frame is where Newton's laws, as stated, the three laws, apply without alteration. F equals ma. An object in motion is going to stay in motion unless acted upon by an outside force. Action, reaction. In an inertial frame, when you do not have an inertial frame, those three laws cannot be applied as written. Once you are in a non-inertial frame, you have to add on these emergent forces, which emerge when you solve for the equation of motion given a rotational energy.
I think what you're overlooking, Doctor, is electromagnetism. Electromagnetism is also laws of electromagnetism. Maxwell's laws are generated from a variational principle.
Correct.
They're not generated from a kinematic law, but they are verified by kinematics in the sense that when Maxwell proposed an integral of all of the laws preceding him in what we call the set of Maxwell's laws, they were then tested kinematically in the laboratory. And there is an electromagnetic equivalent to Newton's bucket in electromagnetism. It's called Faraday's anomaly. When you have a rotating conductor in a magnetic field, Faraday's law, as stated by Faraday and also by Einstein, says that if the magnet and the electric field, the conductor, are co-rotating, rotating together, Lorentz force law does not, predicts zero, predicts that there is no induced EMF. And yet there is an induced EMF if the experiment is done in the laboratory. And where was Faraday's laws done? As almost all original experiments were done, they were done in a laboratory frame, that is, in a frame stationary with respect to the surface of the Earth. So in electromagnetism, we have the equivalent of the bucket problem. We have the prediction of a electromagnetic law, Faraday's law of induction, which is not correct if you take the motion of the conductor and the magnet together, only if you include whether you are measuring from the laboratory frame or not. If the conductor is rotating with respect to the laboratory, then the correction to Faraday's law, using the Earth as the inertial frame, does correctly predict that an induced EMF is produced. So it's not just mechanics, but electromagnetism, which validates the fact that only in the Earth's frame, the lab frame, does an observer correctly predict, by applying Maxwell's laws to the observation of an induced EMF.
Okay.
So it's not just Newton's bucket.
So
It's many other mechanical experiments. It's also Faraday's law and electromagnetism, which reinforce the fact that only if you're in the Earth's reference frame can you apply the laws of physics, which include Maxwell's laws, correctly and predict will be observed electromagnetically.
okay. So this again goes to the basic point that I'm trying to make, or have stated over and over again. Well, first, let me state this. I am not certain if the same sentiment about Newtonian laws applies for Maxwell's equations. I think it does. I could be very wrong, but I would assume that Maxwell's equations as written also only hold for inertial frames, but I'm not going to hang my hat on that. But again, the Earth is not an inertial reference frame because the non-inertial components are small given the typical experiments that are done. So you can talk about bucket, you can talk about Faraday's law, and this is the reason why I was asking about the difference between an observation and a measurement. An observation is just something that you observe. A measurement is something that comes with error and precision. So if the effect is not large, such as stellar parallax, one can mistakenly believe that that doesn't exist. However, if one achieves a precise enough measure, then the reality of it comes into play. And in this case, if you measure precisely enough, you can, in fact, find that the Earth is not an inertial reference frame, not only because of motion, but because of the gravitational field that it generates. And I'm sure the same can be said about those that E&M experiment that you mentioned.
I got it up on the screen. It doesn't.
Okay.
Yeah. The slide that I'd be interested in is the what's the name of it? Stellar parallax.
Okay.
Okay, the claim is made that the Earth rotates around the sun because of the evidence of stellar parallax, which is the observation of a far star relative to a near star at different times of the year.
On the most simplest basis, yes, that's correct.
Okay. Let's see. Alan, can we get the stellar
Already up,
parallax
sir.
slide?
Oh, we already got you. We're ahead.
Yes, sir.
Shown on my
Already up.
stream as well. If you would like to reference it, you can click on the watch stream function.
If you mouse over where it says live on my name on Discord, you click watch stream on that and it'll pull up the thing that I have. It's your slide, stellar parallax, showing the geocentric equivalent where the angle is just due to the sky moving in the state with respect to a stationary Earth versus the model that the Earth's motion produces the angle.
Yeah. I don't know exactly where I am here.
It's all right. As I had this discussion with Austin, is that yes, from relativity, one can state that the Earth is moving around the sun, that will produce a parallactic effect, or the sun is moving around the Earth, which will also produce the same parallactic effect, assuming that the orbit itself has not changed. That is not in question. Which brings me to the relevance of what I was saying before, which is you're stating that the Earth must be the center of the Earth is the inertial frame. It is the absolute reference point. And
dynamics. Yes, in dynamics.
Okay. So yeah. I only brought up stellar parallax as an example of a phenomenon that was originally discarded because it could not be seen because the precision of the instruments was not good enough. In an analogous way, the non-inertial effects of a lab environment due to the movement of the Earth and gravity are also not observable unless your instruments are extremely precise.
The motion of the water relative to the Earth, is that perceptible?
Uh, motion of what? Are you talking about the oceans?
The water. No, the bucket. The motion of the water in the bucket. You're saying that you can't detect these low level effects of rotation of
No,
the
that is,
Earth.
well, yes,
Uh,
yeah, go ahead. No, what
All
I'm
right.
saying is that you cannot detect a low level. You are stating that the reference frame of the Earth is absolute. That is an inertial reference frame. And I am telling you that that is not the actual case. If you measured the motion of, say, a ball rolling down the table, and your instruments were precise enough and your experiment was well designed enough, you would notice non-inertial forces acting upon that ball, which would seemingly want to move in a straight line.
If you're doing measurements of the motion of this ball rolling along, how are you concluding that it's forces, which is dynamics?
Because we can accurately predict the motion of that or the deflection of that ball due to rotation. We can also presumably, well, yeah, due to rotation.
All right, we're talking about, as I said, barely perceptible rotations with respect to the Earth. A ball rolling down an inclined plane
I'm not talking
is,
about the ball rotating. I'm talking about the Earth rotating, which causes a deflection in the linear motion of a ball as it moves forward.
and I'm saying that that can be caused by the motion of ether wind,
Okay.
and and the only way to distinguish those is to consider other experiments, and the other experiments to consider include Newton's bucket and similar experiments, which show that only the laws of physics only apply when the observer is stationary on the Earth's surface, the Earth lab frame.
Newton's bucket, as you have stated, defines that the Earth is an inertial frame.
Oh, doesn't define it, measures.
How does it measure it? To
We
what precision?
measure
To what?
the surface of the water.
Yeah.
The surface of the water is what is being observed,
Mhm.
and it is either flat or it forms a vortex.
It forms a vortex of a particular shape.
Yeah, parabolic. Yeah,
Yeah. Well, is it truly parabolic? Or is there an
that's
effect
not.
due to the or is there an effect due to the move or the non-inertial the acceleration of the Earth's frame?
The effect that we see is that the motion of the water can be predicted only if you use the laws of physics in the Earth frame. You're on the bucket, you see the water stationary, and you predict erroneously that uh, the water will form a vortex. Excuse me, the water will be flat because there is no rotation. So that is not my definition. That's not my assertion. That's my observation of what Newton's bucket experiment shows. And
Ex-
that's what the scientific method requires, that
Scientific, so the
you,
scientific method
you
requires
do the observation.
measurement. You are not
Yes,
giving me
confirmation.
measurement. You're giving me observations. But to be honest with you, I think we're just going back, just going round and round and round. So
Well, there's a lack of fundamental agreement. That's definitely obvious. I don't know how to say it any clearer form that the Earth
I
is the only reference frame in which we can predict the motion of the water, and it's not something unique to Newton's bucket. That is, it's not a freak experiment that disagrees with all the other experiments. It agrees with every experiment that's done, which is not in the Earth's frame, does not correctly predict the motion, the observed object. The only way to do that is use the Earth frame and then transfer or transform your measurements in the Earth frame into the moving frame, and then you will correctly predict the motion of the objects.
So you've been stating that you want to use the scientific method to do this. Scientific method is going to require precise predictions of the shape of that curve, not just a qualitative, oh, it's parabolic. You will need to be able to define what that curve is precisely, because that's the crux of my argument. Crux of my argument is when you do that, when you measure that curve with precision, you will note that you are the person that is in the Earth's frame is in fact not in an inertial one.
Look, the water is simply used to detect the presence of a force. If we replace the water with a vertical axle rotating with a horizontal spring, which is one of the what do you call freshman physics experiments, where you measure the centrifugal force using a motor with a vertical axis and a horizontal spring, so that when there is a force on the spring, you can predict what the value of that force is from Hooke's law and see if it compares with the same prediction from the centrifugal force law. So we can forget about the water. We can forget about all of the things that
I
are
don't think
side
you
issues.
understand. So yeah, when we talk about not or understanding ourselves, again, I don't think you understand my perspective. When you talk about a high school or a college experiment, the precision of those instruments are incredibly crude. There is no way that a college student is going to be able to use those tools to determine that they are in fact not in an inertial frame. But we do have tools that can do that.
Clearly, the crux of the of the impasse here is that Bennett is saying there's a stationary lab frame. It's an inertial frame, that being the Earth, and that we're stationary, at rest relative to the Earth. It's usually a stationary lab frame, and that Newton's experiment shows that. And you are saying that a more precise measurement of the parabolic vortex nature of the water in the bucket experiment would actually show that the Earth is non-inertial. And then we kind of keep going back and forth between that. Are you suggesting that specific thing has been done with these quote unquote more precise instruments to show the claimed non-inertial nature of the Earth?
About Newton's bucket? No, I'm not claiming that. But I am claiming that there are experiments that demonstrate the Earth is not a inertial frame. I don't know what they are because, again, this is not a debate. And as Bennett was saying, he did not come with examples. I did not come with examples. I can provide them later if you would like, but there are experiments that I know of that have been done that demonstrates the Earth is not an inertial frame.
Could you just list those so that I could give a written response to whatever you consider as experimental proof?
When I have them, I will provide them.
Oh, I thought you had them.
No, what I just said was that because, as you stated, I'd asked you for historical records. You did not have them because this is not a specific debate. because of that same thing, I do not have these experiments on hand.
Yes, but I didn't raise the issue of you have additional proof of that the Earth is rotating.
So, in my understanding,
you raised the issue of how many years back do I consider that the Earth was created?
yes,
That's kind of off the wall.
and I don't believe it is, because I'm asking for because if you assume, or not assume, if you go by conventional science or what astronomy tells us, then I have an answer for you as to what was before the Earth. I can give you a geometric argument as to why the Earth or the Sun could be considered the center of the solar system. So I was asking you about the beginnings of the Earth because I was curious as whether or not you could provide the same. So I will reject that you're going to hold me to a standard that you yourself are not holding to. If you were demanding that I show you evidence, because this was not a debate, this was simply a conversation, you yourself are not going to provide evidence because of that fact, then I do not need to provide evidence at this moment because of that. As I've stated, I would be glad to share it with you when I can find it. And I would be happy to email it to you. But I'm not going to be held to the standard that I have to have it, or it can't be, or it's completely bogus.
You don't even remember the topics. You don't remember the text.
I remember the topics very well, sir.
Yeah, well, that's all I'm asking for. What are the names of the
Oh, you mean
topics?
the topics of the experiments? No, I don't remember them off the top of my head. But I will.
Well, I thought we were going to talk about geocentrism, and I thought that would be a relevant preparation would be to present experiments that
Well,
prove that the Earth is rotating.
to be fair, you claim that the Earth is geostatic, not geocentric. But
I didn't claim it. I didn't claim it's geocentric.
but you said the debate was about, or the discussion was about geocentrism.
Yes. But I asked for the definition, and you sent me an email which was ambiguous about what a preferred location in the universe.
Yes, I don't know how
Well, you
that's.
did.
I don't know how that is ambiguous.
Well, you mean the center of this solar system? You mean
I
the
mean
center
that.
of? You
Yeah,
mean the center of the Milky Way? You mean the center of the local group?
I
You mean the
mean
center of the Virgo cluster? What?
I mean that it is a preferred position in space. That the physics here are different than the physics anywhere else. That there
Well,
is
I
a
agree with
reason
that.
why.
I agree with that.
Okay.
I'm saying that dynamics is only applicable here on Earth.
So
That's
that
the
is my
only place.
definition of geocentrism, is that there is a
Well,
preferred position in space.
for dynamics. If you leave off dynamics, then you can always resort to kinematics, which I agree relativity applies, and there is no such laws of physics that are applicable in kinematics. So the statement always has to be included that this applies in dynamics.
All right. But we also seem to be at an impasse as to what kinematics actually can do.
I agree that you can infer laws of motion don't depend on any of the parameters that you use in dynamics, like mass and force and moment of inertia. All of those are parameters that are used in describing the laws of physics. And they don't apply in kinematics because, I think for the fourth time, the only thing you measure in kinematics are the motion variables.
I know.
Nothing else. Nothing else.
Like I said, we're at loggerheads when it comes to that.
And it's seemingly the same is the case with the bucket experiment. And
Yes.
that's the only reason I interjected was not necessarily to put anyone on the spot and say, give me, I'm just trying to clarify for everyone here that you're kind of under the assumption that if you were to make highly precise measurements of Newton's experiments, that would be the result. Is that kind of your position? And then
That is
therefore,
my-
yeah. So you guys are at an impasse, literally.
yeah. Until I can give you proof positive of that, then yeah, we are basically at an impasse for it.
Oh, anything else you guys want to?
Well, that's a pretty good modicum of how we are in modern science, right? At an impasse. All right.
I don't know if we are in modern science in that case, but I do want to ask about.
Are you open for
I do want to
a
ask
couple
about
questions now with your? Yeah.
I was going to ask about
he's on limited time. No tanks, so we're just gonna let them
Oh,
finish
shit.
it out.
Is it 9:30?
Yep. Just
Oh,
turned
wow.
Just turned 9:30.
Oh shit! All right, so yeah, that's basically my hard stop.
Do you want to answer any questions, or you need to go literally?
Let me answer two.
Okay.
I'll answer two questions.
Couple super chat questions here. Okay, if the dark energy claim is required to explain the quote unquote illusion that Earth is in the center of the universe, wouldn't geocentrism be a more viable model, as it does not need to affirm the consequent and reify quote unquote dark energy?
What an excellent super chat.
Okay, so
Must have been changed.
So the question is, if you can create a geocentric model, and I think I've already been asked this before, if you can create a geocentric model or geostatic model, what have you, create a geocentric model in which cosmology can be explained without the use of dark energy, would that be a preferable theory to the one we have now? And when I say can describe the cosmology without dark energy, it can describe why it is that we see that the Hubble constant is different based on measurements of the supernovae, for example. Then yes, I would say that is true. However, I do not see that in evidence.
Okay.
Second question.
Dr. Parks, what exclusive evidence that isn't applicable to a stationary Earth supports an Earth in motion around the sun?
Oh, strictly speaking, that the Earth is going around the sun. Oh, that's a fascinating question. So, a lot of the evidence that I could give you can easily be explained via relative motion. So, parallax can be explained through relative motion. Doppler shift could be explained through relative motion. My question would be, it's difficult for me to, from an Occam's razor standpoint, it makes far more sense to understand the physical mechanisms behind how the Earth was created and ultimately was formed around the sun, causing its motion around the sun relative to the background field of stars, than it would from a formation mechanism such that the Earth is stationary and the stars themselves are in fact moving. This is particularly notable in terms of the variable rotation speeds of the Earth. When you look at the rotation speeds of the Earth, if you look at it relatively speaking, the length of the day changes up and down measurably by, I think it's microseconds, it might be even less, but it's measurable. And it varies on, I think, maybe a weekly basis. Anyway, the point is that it varies. So you're left with the question of, is the Earth rotation changing because of the internal moment of inertia of the Earth? Or is it changing, which we have models to show that, or is it changing because the universe itself is changing its rotational rate around the Earth?
It'd just
For
be
me,
the sun, not the whole universe.
well, I mean, so you can either say that the Earth is going around the sun and the sun is going around everything else, or you can say that the Earth is stationary, the sun is going around the Earth, and then everything else is going around the sun.
Yeah, yeah. I was trying to make sure I understood. You said the length of the days change, right?
Mhm.
So
Length of the day changes, yeah, based on
sun.
the length of the Earth's rotation changes.
Yeah. So are you talking about the changes that they make to UTC to UTC1, the microsecond adjustments that they do? It's based on the movement of the sun moving through a quasar grid system that they established. Like if it goes through a little faster that day, they adjust it by 0.00 microseconds or whatever.
No, that's the equation of time. What I'm talking about is random motion or random changes to the Earth's rotation based on the internal structure of the Earth's core. PhD Tony would be the person to really speak to this.
Guess we won't be talking about it.
Yeah, I guess we'll never know.
Yes.
So unfortunate.
I will. Well, how about this? I'll ask him, and then I will let you know what his.
Okay, yeah. Please run it through the filter of Professor Parks's patience.
All right, gentlemen. Like I said, I gotta go because I've got telescope to fix.
Okay, Benny, you want to say? You want to say?
If I can answer one.
You can't. There's no time.
Yeah,
All right.
I was gonna say, Benny, you want to say anything to Professor Parks before he gets out of here? You guys want to maybe coordinate beyond this conversation or for future discussion or anything?
Yeah, I wanted to thank him for coming and addressing a actually hostile audience. And I've been in a situation where I've gone to bulletin boards that are purely mainstream, and I received a lot of flack, a lot of ad hominem attacks. But I appreciate Dr. Parks for coming and discussing the issues, even though we can't resolve our differences. I think that we should take what the other person expressed as counter arguments and consider those in modifying, if necessary, our own position. But again, thank you, Dr. Parks, for coming and facing the hostile audience.
Well, I will say that I didn't really face the hostile audience because of my time cap, so I will grant. I will give that to you. But you don't really. So I would say that's. You shouldn't give me credit for that. But thank you for having me. Thank you for coming and having this discussion. It has been extremely illuminating. And yeah, I want to have these kinds of conversations that are civil so that I can fully understand the positions that we're in. And obviously, I'm not going to change your position with one conversation. And you're not going to change my position with one conversation. So this is going to have to be an ongoing interaction where I supply I supply supporting evidence to my side. You will comment on it, supply supporting evidence to your side. It'll be a back and forth, like science should be done. Among,
you're a few steps away from geocentrism, brother.
No, I will disagree with that. But again, thank you. I got to run. You guys have been great. Bye. Peace out. Please, guys.
Thanks for coming, Parks.
Thank you,
Those are some of
Parks.
the best super chats I've ever heard. Whoever sent those.
Yeah, someone came in the clutch with that super chat.
Guys, kind of frustrated trying to get my ideas across. Are there any suggestions for improving?
Well, I think you did. I think you did a great
the
job. I wanted to
arguments?
get in earlier before we left.
Yeah.
Well,
So
I
this is
don't know
what
if
we
I
deal
was
with on
suggesting
the
exactly
regular,
what.
bro.
Yeah, I think you did a great job. The only thing I wanted to ask Parks was, you guys really had like a standoff there with the kinematics versus dynamics. He says he can make predictions. He says he can make predictions using strictly kinematics. So I would have just maybe asked him. Maybe he has an answer, but if he could show a single prediction using strictly kinematics without any kind of dynamic forces, and what is that?
Yeah, that would have been a good question.
well, but this is the
Yeah.
thing, right? He'll conflate post-diction, for example, like even the kinematics of the planetary motion, or you can use a kinematic equation to determine the rate at which something will fall, right? Like I think he actually did invoke that, right? Talking about like height and initial velocity, etc. And
I
although
mean,
those obviously would involve dynamic forces, yeah, like once you have established what's going to happen and then observed it and measured it kinematically, assuming it remains the same, you could take
Yeah, I
that
just don't see how
post-diction
it's
and
gonna.
mislabel it
Yeah,
as a prediction. That's my
of
take on
course.
that,
Yeah.
at least. Yeah.
Yeah, I don't see any possibility like whatsoever. Somehow, somebody making a prediction without observing the cyclical cycle or
Uh-oh.
repeatability of a situation as either one factor or the exchange of the interaction of materials within physical dynamics as the other part. So him claiming and you guys being at a standstill on the kinematics and dynamics was a little disappointing, but you did a great job. Great job.
Well, but I'll give you my
Well,
input,
one,
right? Like he had the ability to hide, or okay, I don't want to phrase it in any type of like implied disrespectful way or whatever, but the whole "it's not a debate, it's a discussion" thing is really what like pigeonholed the conversation, because his rebuttal to your primary position was that although it appears to be inertial, it's not. And if you had precise enough measurements that would that would be shown to be the case, trust me, bro. Basically. So
Yeah, that was
eh,
a trust me, as they say. I didn't like the young Earth sort of like let's establish how old the Earth is. I think that took up about 15 minutes, and I personally wouldn't have entertained it. It has nothing to do with
Although I did like he went
the
right to
topic.
eclipse cycle to name like three of the main scientific stuff right up the top, and Brett Parks was like, "Nuh-uh." Well, that's not what I wanted to hear or
Yeah.
whatever he said.
Yeah, that was
yeah,
like
what
that was like gain ground back where he was losing it prior. Yeah.
But
what
like
day did the
reasonably, like the age
years
of
start?
the Earth or not has nothing to do with the discussion at hand.
yeah, all right. But all right, Dr. Bennett's tried to get in like 3 consecutive times. What's up, bro?
Yeah, well, the remember when he's talking about the falling object, Galileo measuring the acceleration of free fall, and I said, what if there were a sideway force, uh, which is dynamics, because there are no forces in kinematics. He said he would convert the force into an acceleration and a v. To do that, you have to know dynamics. You have to do that. But he then he seemed to change whatever I said and to bring it to an extreme by saying whenever I described the Newton bucket experiment and its results, he claims it was my assertion or my definition. And I was careful to only explain what the observation of the motion of the water is, and that's frustrating because you're really not communicating. Um, honestly, I don't think if you don't
Yeah, same.
Dr. Bennett, you did a great job. I don't want you to think it did not go unnoticed that he could not concede to the difference, the very clear difference between kinematics and dynamics. You really drew him out on it. You did a great job that he wasn't able to concede it because he needed to hold on to his predictions as in that way.
You guys say able to concede, but really it's like held on to a retarded point because everything hinges on it, was how I saw it. Maybe you guys saw something different.
Exactly what I. Yeah, no, you just said what I said. Yeah, it was very clear to see that he was just holding on to it, and he wouldn't let it go
Well,
based
he's
upon the consequences. Yeah.
right. Yeah, exactly. He's smart enough to know that from there the whole thing falls down, which is why he's being held to the fire there. So that's why, the rule of being a glober or heliocentrist is duck, dive, duck and dodge that question.
So his primary thing was an appeal to possibility, which is a logical fallacy
Right.
of taking
Right.
something for granted because it's possibly the case.
Yeah.
Yeah.
That's why when he says that if you did careful measurements of the parabola of the water surface, that you might find that it varies from centrifugal force. But we're talking about a general observation.
I laughed so
not-
hard when he said
not
that, by the way.
not molecule by molecule what the water molecules are doing.
I laughed so
It,
hard when he started saying that. I was like, get the fuck out of
By the way, that's another. I'm offering another bet. I will 100% bet that is not the case. That you will not use any instruments known to man to measure the water in that bucket that will correlate with the rotational claim, an axial rotational claim. So I'm willing to bet up front right now. That's just completely not the case. I don't even understand what that means. But I. So to me, that's what was frustrating.
It's the argument that if you did very, very precise measurements, you would find that your observations are not true. So
ever about
I don't know how
anything.
you, I don't know how you answer that.
No, you can't.
Turns out nothing matters. I can never know anything. None of my measurements can ever be totally accurate. So why measure anything, I guess?
This is what's refreshing
the
about him.
point.
This is what's refreshing about him, though, in my opinion. He believes it, meaning he truly believes because of his assumption. So it's affirming the consequent. It's kind of reifying the concept of the model of the Earth that he believes in. It's backing the question. It's appealing to possibility. It's appealing to the future. It's many fallacies, but he believes that the Earth is doing that. Therefore, the necessary implication would be that with precise measurement, you would be able to see some deviation from an actual inertial frame. So like that's all that was kind of going through his mind, I think, was that he said it with that amount of confidence because it was basically demonstrating the confidence he had in the rotation assumption itself. Does that make sense? I don't think it was like malevolent or deceptive. I think it's like he just truly has internalized the belief.
That reminds me to tell you, Dr. Bennett, that you were not out of line whatsoever when he said, I have done tons of tests to show it to be the case. It's like he offered them up, and you were like, oh, awesome. What are they? And then he was like, how dare you
Oh,
ask me for them?
I don't have
Yeah.
a single one actually, but how dare you ask me, sir?
Yeah. Yeah, I'm sure we have the slides to contradict it, right, Alan?
Well, I thought that was
Whatever
funny because we've been asking for those
Yeah,
forever.
the whole time you were talking, I was pulling up all the relevant stuff from your prezzies.
Yep.
Everyone got to see it as the conversation was unfolding, and
It
was
was
just streaming that. So,
Dude, the audacity of that guy to
did an
claim it.
experiment.
It's like, no,
Yeah,
we
as
have
if he did
tons of them. We've been sniffing for one for as many years as we can. We say it all the time. Oh, you have a dozen, a list even? Could you present it? That was so smooth. Could I see it? Could I get a peek? Could you email it to me when you're done or whatever?
How dare you? How dare you ask me on the spot? This is not a debate. Why? You
100,000
said you had 'em.
physicists agree with me. That's all right.
Yeah, that was
Don't
hilarious.
forget, we were both subjected to the same indoctrination. We all went through mainstream education. The thing that differs is that he continued to believe, maybe because of his position.
Well, he went through a lot
Because
more indoctrination too.
there's a lot of pressure. You could possibly lose your job, or be demoted, or given a trash job if you oppose the mainstream thought. But since I was independent, I could look into the claims of mainstream physics, like the rotation of the Earth and so on, and I could investigate it myself. And the internet has been a big blessing, because I used to have to go to the library in order to look up all these references. And that's very time consuming and expensive too. But now with the internet, we can do research. In fact, we can do group research, as we've been doing with you guys on the ether cosmology. But I can't get over. He asked me, how old did I think the Earth was? I thought did he mean to the day, to the actual length from the present all the way back to when the Earth was great? I never expected a question like that
You know,
on the topic of geocentrism.
but
So
your answer was spectacular. You repeated it 3 to 4 times. He still had no idea what you meant, and because the answer was a direct refutation to what he said, it was beautiful.
I don't know what he expected me to say, but
Like, well, the radiation half life. But how do you actually confirm that the radioactive half life of the chemical that you just based the whole dependency for the scientific notion on? What? Well, yeah, like the basis for what you just said, it was so funny because you were so exasperated, but you explained it so clearly each time, and then he still pretended not to understand it, because to understand it would require that he had to answer it, and the only answer you could possibly make is they had direct refutation. So, man, what a trap!
Or that you just assume it, right? The answer is that they just assume it. They assume perfect, idealized initial conditions.
yeah.
So
Yeah,
I
I
so
thought he was
totally
going to
if
say
agree.
he
you
had some kind of experiment of them spinning a bucket for like a year straight or something. I don't know what he was going to say, but he said he had nothing. He said, "How dare you ask me?"
yeah, yeah, I was prepared to give counter arguments, but yeah, when he mentioned stellar aberration, I said, "Oh, good, he's going to use that to prove that the Earth rotates around the sun, because that's what all the textbooks show, right?"
Mhm.
And then when we get to the slide, he says, "Oh, no, no, that's kinematics. I understand that that's relative motion, that it could be the Earth or the sun that's in motion." All of a
Dude,
sudden, when you had the slide available, oh no, no, that's not a proof of Earth rotation.
Yo, when I
Uh,
asked that, whenever I read that super chat, his answer was, "Well, pretty much everything would be equally explained with geocentrism." Like he said, aberration, retrograde, a couple other things, and then he said, "So basically, the reason that he thinks the Earth is not stationary and is moving around the sun is because of things like where did the Earth come from and how was it created?" And that's a wild
Yep.
position. So,
I know, dude. It got you. I mean, you did it right on, Dr. Bennett. Like, are you asking me a theological question or not? Because that's what he was. That's what he was getting at. Yep.
And what's
you know
I'm
it?
what
fine
comes
doing that.
after? You know
I'm
what comes
fine doing
after
Whenever
that for the
stellar
science.
aberration?
Yeah.
Mary's failure. That's right where it leads to. That's why it was like automatic. Oh, let's move on.
Yeah.
that's a great point. Yeah.
I'm under the impression Dr. Parks is he not a Christian? I was under the impression he was.
So yeah, he says that he's a Christian, but that he doesn't look to it as a science book, and keeps it wholly separate from his professional views.
No worries. I was just a little bit thrown back when he asked that because it was intuitively like Dr. Bennett called it out intuitively. It was a God question. He was where did all the material come from?
Well,
And what's your creation story?
it was a pre-set up gotcha God question, which was weird to see from Professor Parks, to be honest.
Mm.
I was just going to mention, wasn't it true that whenever you had him on in the field, he did not subscribe to relativity?
Um, Pretty much, yeah. What he said was he's pretty much positive that it'll be done away with and that it's not correct. But that he's satisfied with it in its current state for intents and purposes until something better is found.
Yeah, I
What an
found that
answer.
interesting.
What an answer, dude.
Yeah.
I mean, I guess if you were gonna find someone that was gonna just embody the correct teetering of the line on the mainstream to like hold it, he's the guy, right? For
I think
sure.
it's refreshing that someone will defend the mainstream model, but typically just straight up tell you like, yeah, I'm just assuming it, and to me, it makes the most sense, and I just believe it.
Because that's genuinely the most convincing answer. Because I believe most people, I believe that those are the top 3 reasons for most global believers still, right?
Well, I hear that a lot, the sort of sheepish, yeah, it's not perfect, but it's the best we've got with a lot of aspects of the globe
Yeah, like honestly,
model.
that's the honest answer, I think. But he just comes out and says it, and then
Mainstream claims that they follow the scientific method. Almost all of their arguments appeal to the majority, appeal to what has already been decided is the thoughts of the elite. The high priests have spoken, and that we are uh, to assume that everything that mainstream promotes is correct, unless there is overwhelming evidence that there isn't. And getting overwhelming evidence in view of the fact that these guys may sacrifice their jobs, their position, their pride, their uh, social standing, all of that is involved in keeping the party line, in following whatever the mainstream promotes.
There actually is already overwhelming evidence, right? Like the dark energy. So, like you said, the priests have spoken, which is a hilarious way to say it. That's what it is. Like the priests have spoken. There's nothing else to discuss. But there's an overwhelming amount of evidence already. Basically, it's the priests have to speak again. It's only when the priests decide that we're going to acknowledge that overwhelming amount of evidence and then update can they do it, right? Because, like for example, the dark energy thing is a perfect example where we made deep space observations that show that everything moved in relation to the Earth. So we had to come up with this idea that it's just an illusion that the Earth is in the center because everything's accelerating and expanding away from every other point. Therefore, you need some type of energy to do that. And then we found some vacuum energy. We're like, oh, well, okay, if we assume there's a vacuum of space, that must be vacuum energy up there. And that's what's doing it. And it was off by 10 to the 120th power. It wasn't even close. And so they just keep it there. They just keep dark energy there. But if you go back to where the assumption that made you invoke dark energy in the first place, and you re-examine the options, the obvious option on the table is, oh, it appears that the Earth's in the center because it is. And then you don't even need dark energy. And the same goes with dark matter, and it's off by 99% for Zwicky, coma clusters, Farrah Rubin, galaxy rotational speeds, 1955, and on and on and on and on. The evidence is overwhelming, right? It's just that it's just on pause until that priest class comes back in and says, "Okay, we're gonna change things up." And I don't know. It's just wild to watch. I think you nailed it. It's because of the public pressure, the professional pressure. It's effectively like coercion, professional coercion. So it's not like I don't lack empathy. I'm sure you understand it, but it is a sad state of affairs in terms of potential progression.
You know what Wolfgang Pauli said, Austin, that the laws of physics only change when all of the old guard, the old guard die. Oh, excuse me. And I
Yes.
think it's pride. It's a lot of pride is involved in the refusal of these guys to look at scientific evidence that follows the scientific method. Say to themselves, but how foolish am I going to look when I have to say that Big Al Einstein was wrong and all of the things that we've done since almost the beginning of the 20th century, except for quantum mechanics. Almost all of it is junk. All of it is, in fact, contrary to what an interpretation would be if you were free thinking and not subjected to human pressures, and you were objective scientifically, and you followed the scientific method, which is ideally what all of us are supposed to be doing. I think that the root cause of the inertia of mainstream science is their pride, their internal pride, and knowing that it would look foolish if they had to recant all of the, not all of the things, but some of the things that they've promoted.
Absolutely, yeah, I agree 100%. Actually, in the documentary you were in, right? Michio Kaku basically says that. Like everything I've studied my entire life is wrong. And
Oh yeah, that's the Webb telescope discoveries, right?
yeah, the CMB.
Yeah, he's rethinking the observations of the Webb telescope, and why do the galaxies seem to be brand new, even though they're a gazillion light years away?
Right. They're way too
And
formed and
yeah, they're young galaxies, as they say, and of course they say they're young because presumably they can measure the spectrum and determine how many minerals are present, and then they have a model of what the main sequence of the development of a star is, and all of that is fiction. All of that is a model that may or may not be true. Uh, and certainly the Big Bang model, that's certainly scientifically and theologically certainly uh, is well, it should be on its way out, but still they hang on to the Big Bang model. That something came from nothing and exploded, and we're now living in a expanding universe, which is their interpretation of redshift. But redshift can be interpreted by the assumption that stars release ether along with their emission of light. So if there is an ether wind accompanying starlight, it will be redshifted. I can show you that mathematically. So you would get a redshift if the stars were producing ether winds, like Hildegard says, or the other interpretation is a Doppler shift. Mainstream says only the Doppler shift is what they believe. That's the only explanation for a redshift. So those are some examples of things that have to be corrected in mainstream, uh, as far as my humble opinion. Yes.
yeah, and I think there's even a few other possible examples for Redshift specifically. But so this is what I found is there's a few things that are not up for debate, like meaning that they're never allowed to be examined or reconsidered. So with this, like say the James Webb observations, and for those who don't know, basically they're claiming to look out super far into space, so closer to the origin of the Big Bang. And so it's the oldest portions, and the galaxy should be super old, but they're given characteristics that would make them super young. And one of the fixes, of course, someone's proposed to just double the age of the universe to 26 billion light years, and or 26 billion years, or whatever it is. And then someone else has proposed, or someone else has hinted at the idea that, well, the interpretations of the galaxy's characteristics themselves is incorrect. And the reason I'm making that point is they would revamp something that big. They would say, oh, well, the current method we have to interpret like the chemical composition, the material composition, except the luminosity, the masses, etc., the gravitational fields even of the galaxies is wrong. Before they ever step back and reconsider that the original assumption, the Big Bang assumption itself, right, would be wrong. And they do the same thing with the Copernican principle. whenever we observed that the Earth appeared to be in the center, and then they had to have dark energy, and then now it's been over a century basically, and they still can't fix the dark energy problem. They never go back to reconsider that the cosmological assumption's wrong, like fundamentally, like the Copernican principle assumption's wrong, that we don't occupy a special or unique position. Same thing with dark matter. So, they plug in missing mass in 1933, then they end up calling it dark matter. So there are people that are proposing modified Newtonian dynamics almost everywhere. It's the elephant in the room. We know dark matter is not actually a real thing, but they'll never go all the way back to the core base assumption, which is the Copernican principle. And so I think it's twofold. It's maybe threefold, I guess. It's the professional pressure, it's the pride entailed with doing it professionally so long, and then it is the philosophical bias of the implications of a special position, or the philosophical bias against those implications, right? Like if the Earth is in a special and unique position, what does that mean? Why? How to get there. If it's in the center,
Yes,
who put it
somebody.
there? Yeah.
Yeah.
So
Yeah. Did you ever notice that they get the distance, the edge of the universe, from the redshifts, and each time they define as certain distance in light years as the radius of the universe, then they discover a star or a light source, I should say, that has a bigger redshift, and then they have to increase periodically. The size of the universe keeps growing as they discover more and more higher redshifts. So whenever you pick up a textbook, you have to look at the date of the textbook in order to find out what did they think when this was printed. What was the size of the universe? And as far as the philosophical background, I would require that if I did a debate, that the person would at least accept uh, realism as their fundamental belief. If a person says that they're agnostic or a nihilist, it couldn't possibly be a scientist, because a nihilist says that there's no truth at all, and an agnostic says there is truth, but we can't find it. We can't know what it is. In either case, how could you do science if you're an agnostic or a nihilist?
I wonder if you should
So
add to
I'll
that list of requirements to the kinematics and dynamics equivalent requirement, differentiation required or something.
yeah. Look at how difficult it was to get the concept of kinematics, the distinction between those two.
That's
Um,
right.
We must have spent half of the time on going back and forth. And he's saying I'm defining what kinematics is, or no, asserting that what it is, and um, this is the accepted definition. Kinematics is the measurement of um, the physical world, and dynamics is the evolution of the prediction of new laws using the Euler-Lagrange equations. I didn't want to get into that because that is something that would probably put you guys to sleep, but that is the basis.
I even tried to come in and
basis
bridge
of
that gap. I tried to bridge that gap, and I still could.
Yeah.
It was like he didn't want the gap to be bridged, or so. I was like, well, kinematics, observations, measurements of motion, moving variables. Okay, mathematical descriptions, measurements, science, physical laws of physics, explanatory. So you have descriptive and you have explanatory, right? Causal mechanisms, cause and effect, and he wouldn't just even take my like kind of concise bridging of the gap,
But
right?
he
And
chose to die on that hill, and he was not going to be rescued by you, no matter how hard you tried.
Well, I've seen that take 2 hours to be acknowledged on Flat Earth Friday, just the basic kinematic equivalence.
Well, so don't other PhDs usually agree to that? Isn't that one of the sticking points that this type of atmosphere would usually get rid of?
Oh no,
That was it.
but Parks does, right? Like you're never going to talk to a PhD astronomer astrophysicist, certainly one that's showing their real identity publicly if they're active in the field at all. Like almost no one. I mean, there may be some weird exception that's going to fight you on the kinematic equivalence. That's not Professor Parks doesn't do that. But he was fighting him on like the proper defining of those two terms and the distinction between it, which was wild.
Oh,
Yeah.
yeah, that makes
I
sense. I
thought
misunderstood.
But he knows because because he listens to us all the time, so that's why he had to have his own specific interpretation or whatever to not agree with, right?
You
Because
got that custom
dude,
kinematic.
he was he was dying on this hill no matter what. Like I know I'm gonna redefine it colloquially or whatever. I'm gonna make it my own.
He just kept saying saying the prediction thing. He just kept jumping in saying, "I disagree with you. It can make predictions." And it's like, what? When did I say that? Like, what are you talking about, bro? That's not what our disagreement is.
Bennett, since you made that distinction to us, what was that last year on Wit's show? Been hammering that, and it just like what you experienced is what we've all been going through. Like since you brought it up, and we've been introducing it to our arguments, getting them to acknowledge that distinction is in quite a bit of a struggle. You could say
Tiny uphill battle. You might like a slight bit of resistance.
It's like I have to imagine now. Like, where would this conversation, do you think, Dr. Bennett, would have evolved if he had conceded to the definitions of kinematics and dynamics? I was interested to see where that would go, but he wouldn't concede. Where do you think it would have went?
What if we all just
Nowhere,
redefined
huh?
stuff
Yeah.
we didn't agree
Maybe
with?
nowhere.
I didn't know we could do that. Like if I slightly disagree with you, what if I just redefined what I disagreed with to my own liking, and then I just agreed with that? Is that the same thing?
Well, I've even tried the really simple analogies too, right? Like Austin walks around the pole. We could describe that Austin walks in a circle around the pole mathematically. What causes Austin to walk around the pole? He exerts a force that moves him around the pole. That would be dynamics. Or like a beautiful example is if you're in free fall, say you're on a parabolic flight and you have a knitting needle and you like rub it on some wool or something, you'll get it statically charged and you can drop little water droplets. It'll start orbiting around the needle. It's super cool. And it would be like, okay, the water droplet is orbiting around the needle, right? So that's kinematics. Like we described the motion of all the different size water droplets moving around that needle, that would be kinematics. We just described like their geometric motions and the moving variables. And then if we started to get into the actual electrostatic force that's causing it, that would be dynamics. This is a very simple concept though. Like I find it hard to believe that there's almost anyone that doesn't understand the difference between those two things. Like I think there's something else going on. Right? It's not like it's not ineptitude.
Yet we explain it all day, every day on Twitter.
Austin, did you know that in the famous 1905 special relativity paper of Einstein, there are two main sections? You know what the title of those two sections are? Kinematics and dynamics. So when I looked at that, I said, someone got it straight. Someone is separating the two. And when you go through the text of each section, he confuses totally what is kinematics and what is dynamics. So Einstein, I thought, had the right idea to separate from the very beginning what's kinematics and what's dynamics, but then he blew it totally in the text, in the body, where he used in the kinematic section, he talked dynamics and vice versa in the dynamic section. Maybe that's the start of all this confusion, because people ignore what kinematics and dynamics mean. It's key to understanding the bucket experiment.
Ignore
At least
or
in my mind.
intentionally misunderstand. I don't know if those two things are exclusive. Ignore.
Well, I think they may intentionally misunderstand the simplicity in like my examples I just gave, but what he's saying is pretty interesting. It makes you think that there may be something deeper there, right? Like the actual relativistic framework itself has that confusion embedded in. Like, is this the foundational issue that all these other people's inability to decipher the difference stems from? You see what I'm saying? Now, but that would actually require the average person to have read it or even understand the slightest bit about relativity, and they do not. They do not. And it's interesting. I want to relook at the paper, focusing on that and keeping it in mind. 'Cause it doesn't surprise me. It doesn't surprise me he would get them confused and mixed up.
Yeah, I think it's a source of misdirection, definitely. And you're right, Austin. Very few people have actually read the paper, even the ones who claim to be relativists and are PhDs in physics, because there are a lot of contradictions in the way he manipulates the equations, and maybe that's the way it all began. They looked to that as the source of the confusion between dynamics and kinematics. I don't know.
Or even like
Certainly
the
is
second,
prevalent today.
like the handing down of the paraphrase versions of relativity even still are tainted by it. Because that's really all you get, Like you don't actually get accurate represent. Every time I try to discuss relativity with the relativist, I'm just constantly having to correct them on what relativity says. So, they don't actually even know what it says. And if you I mean, I think I'm preaching to the choir here, but Einstein himself said he doesn't fully understand it. So, I think that kind of speaks for itself.
Well, dude, I think the funniest part is they get to make up their own things. In Alan's presentation last week on quantum stuff, he talked about the twin paradox, and then he went over all the answers, and he's like, over the years, these 47 answers, people have submitted different answers. They're all they all don't agree with each other, and they're all different, and they're all therefore wrong. But people do like to think they've solved it, right? Because each one individually thinks they've solved the paradox, but as collectively, yeah, you're all wrong, right? So I thought that's probably something like that going on.
I got a
Yeah, most of
totally
them
different
directly
feel.
were contrary to what Einstein said. Up to and including the time dilation happened before the motion occurred, which is
my favorite one.
really cool. What were you about to say, Ken? Sorry about that.
Yeah, I was going to say I got a completely different feel for why Parks couldn't agree to the Newton's bucket thing, because I thought Dr. Bennett explained it extremely well. I felt like I understood a lot more than when he first presented it, and it seemed to me like the sticking point was that if he accepted the fact that Dr. Bennett said that observably the lab frame is the inertial frame, he kept going back to the, well, you don't know that the lab isn't moving. And I think he felt like if he admitted that it's observably the inertial frame, and that's what, Newton was talking about, then he had to say that the Earth was still. It was like, if I accept that, then I have to say that the Earth is still. And I that's the sense that I kept getting, because every time they approached the inertial frame, he needed to make a reason why the Earth is still moving. Whether you think it's not really inertial, it's non-inertial.
Yeah, it was frustrating. Yeah, that was frustrating because even you're treating as the inertial frame no matter what, and the movement relative to the inertial frame. So yeah, that was frustrating as a avoidance of contention.
Specific precognizant avoidance, but I just want to keep saying that. He knows what hill he was going to die on.
That's why you can't give the not a debate shield, because that's a very powerful shield.
Yeah.
And it was strong to hear, like Dr. Bennett said, listen, okay, whatever. I'm going to give you, that's the inertial frame in this situation. We're going to observe the movement of the sky. Can we move on? And he just wouldn't move on. Yeah, because of the precog. Yeah.
Yeah, but how long do you think the Earth's been here? No tanks. I can't listen to anything else you have to say.
And how did it get here?
You believe in God, okay?
How did it get here, bro? Dude, I had a debate with him on geocentrism. One day I talked to him in Discord about geocentrism, and dude, I was just letting it off, bro. I was like hitting him with with like the irrefutable positions back to back to back to back. Because I got frustrated with him because I had that conversation with him. He asked me to send him some papers. I did. I then popped in on a Discord. He didn't know I was in there. And he was talking about how I never sent him the papers and I must have made them up. And I'm like, what? Like I sent them to you.
Oh, no.
I
was like,
Glover, dude. All Glovers do that. It's crazy.
Yeah. I was like, I sent them to you the second I ended, the second I ended my live stream, I went and sent him all the papers, right? So I kind of, I'm like, okay, let's talk about it. And I hit him with a bunch of questions. And what it came down to basically is I had him concede on the dark energy point. And I'm like, well, if I don't need dark matter or dark energy in a geocentric position, isn't my model at least 96% more viable? And then, painfully go through 73% dark energy and how we don't need it. And it creates the illusion we're in the center, et cetera, et cetera. And he was conceding, and then of course I got him to concede all the kinematic equivalents for retrograde, parallax, aberration, and you name it. And so then what it came down to, which was very interesting, was I explained to him, well, actually, if you had the angular momentum of a rotating universe, you would have centrifugal forces, a real Coriolis force, and you would have a net inward force. Effectively, it would just keep moving. You would just need something to have set it in motion, and then it would just keep going. And even if it were to slowly lose energy, for intent and purpose, it would be perpetual. And because of the net radially inward accelerative force. And so he conceded that once he fought it a little bit. And what it came down to was he was saying, well, what started it? I don't think that I could say your model was more viable until you could give me a sufficient explanation as to what started it. And I was like, are you going to hold the same standard for your model, guy? Like, what?
Well, dude, he went through that today and then took the opposing position on Cassandra. He was like, well, unless you can tell me how everything became here, because I can. My model can, right?
And I was like, dude, my answer is God. An intelligent agent, not limited to natural law, started it. God, but I'm like, is that not your answer? Regardless, it was on the heels of all the concessions that we don't need dark matter, we don't need dark energy, we don't, there's a kinematic and dynamic equivalence, and actually there's a superior viability in the geocentric model. All these concessions, and then the one rebuttal was, who started it? So I wasn't entirely shocked to hear this exchange tonight, to be honest.
Yeah, like he learned from you and then tried to trap him with the same stuff that he stepped in for you. That's what that was.
Sort of.
I thought I was supposed to say, in the beginning, God created the heaven and the earth.
No, he would have freaked out.
You totally should have said that.
Quoting Genesis.
Probably would have hurt some people.
But that would have been pretty epic, and his face was upon the waters. The whole nine. That would have been
until he stops you.
You said that you were in a room with Parks, and you would hear him telling you how you didn't produce papers and how you probably made them up. Isn't it weird how a nice, genuine dude like that, when amongst Globers, just they bring out the worst traits in each other, and even him through whatever social weird reinforcement club thing they got going on where they want to be included, he immediately was like, "Oh, I gotta make fun of what's it to be included." No problem.
Well, and this is what's weird about it is I don't care. I was we had a decent conversation until he held up a book and told me it was space, and I was like, wait a minute.
That was it. That was the point when you were like,
that's when I was like, okay, we've gone we've gone off the rails here. It's like you can't treat physical properties to conceptual abstractions and spaces of privation, right? So he's like, no. this book is space, Austin. But I'm like, no, that's a book. It's in space, right? But anyway, I enjoyed the conversation with him, is what I'm saying. And so, in good faith, I was saying I would like for you to look at those papers, because I pointed out to him that Luka Popov had already shown a Newtonian Machian analysis, and that Andre Assis has shown a relational mechanics using a Lorentz magnetic force. And so I sent him those papers because he basically kind of pushed back and said, well, if that actually exists, I'd be happy to look at it. I'm sure I'll find something wrong with it. And I'm like, okay. And so I sent it to him. And then this was months later, he was saying that. And so then obviously I really made a point about it. I'm like, go find what's wrong with it. So then when we just discussed again, it was kind of the same thing. It was like, I looked at it, and my problem with it is, well, in order for it to have been started up, it requires some type of energy or something to have done it. It's like, yeah, bro, that's the case for any cosmology ever.
I gotcha.
You know what I mean? So, but yeah, that's why I made the joke. You're a couple steps away from being a geocentrist to him tonight, because he's made all the concessions to be a geocentrist already.
He just prefers to believe it based on faith and personal preference, which is cool.
Yeah.
Yeah, and one of those concessions was interesting because he agrees that the laws were not derived from a non-inertial frame. So if he agrees that the Earth's frame is valid for these laws, how does he not know that the Coriolis effect and Hadley cells aren't sufficient to explain away Earth being in an inertial frame? I just didn't get that approach.
Well, the angular momentum model, Austin, that's also Bob Sungenis model for explaining the motion of the planets and the stars. The angular momentum of the universe provides the centripetal and the Coriolis and what's the other one? The Euler force.
Euler-Euler, yeah. Yep.
Yeah.
And I find it interesting because, we have different models, but there's an overlap. I mean, I say it very clearly. Sungenis put a lot of pieces together for me for what I think, and I just have ideas. I don't know I just have ideas, but I think it's a torus field, and I think everything's a torus field. And in a torus field, you have centrifugal divergence. So you have this motion, of course, moving out from the center. And then you have centripetal convergence, and it's this conjugate geometry. It's this overlap geometry. It's the hyperboloid and the torus field and the toroid, right? The donut and the inside of the donut. And we see this all throughout nature. We see this in the small scale and the quantum scale. We see it everywhere. We see this in magnetism, which is confounding to modern physics. Say it again.
Galaxy structure is toroidal.
Yep, and you have the exact same vortex nature within the magnetic field seen in galaxies. So to me, that makes a lot of sense. You get those motions within just the geometry of a magnetic field. You get this angular momentum model out of that. And I remember I heard Sungenis kind of go the Newton route, and he wasn't defensively claiming Newton. He was just saying, look, Newton does work for us. Like, Newton works for our model, and I have no problem with it. And I do. I have a problem with it. I don't believe in the Newton model, but I believe in that angular momentum concept. It makes perfect sense. And it would, the magnetic field would sustain this vortexual motion basically forever. And I think it explains a lot. Another thing that's so obvious to me, I've been saying this a lot lately. This is so obvious to me. One of the major problems modern cosmology has is their gravity discrepancies. And that's because they think that gravity is based on mass. Everything's based on proportionate mass. And so they looked out at the Coma cluster, right? And it only had 1% of the mass needed to keep the galaxies from escaping. Instead of being like, wait, our gravity theory must be wrong. Like, no, there's 99% missing mass, just fill in the math or whatever. But it's just weird where all the discrepancies come from the assumption of proportionate mass. But if you use the analogy of having like two magnets that are identical in size and identical in mass, they could have vastly different magnetic field strengths. And so you're not limited to mass. Whatever the accurate model of what's going on in the sky is, it isn't limited to proportionate mass. It's not. you know, and that solves all the problems. We don't have to invoke like fairy tale, you know, substances like dark matter. I don't need any of that. It's like, no, that galaxy has a stronger magnetic field. That cluster has a stronger magnetic field than this one over here. It doesn't matter how much quote unquote visible mass there is. It's just different magnetic field strengths. Or maybe you would invoke something more with coherent electricity or whatever. That seems so abundantly obvious to me that that's a superior position. Not being limited to proportion to mass is so superior. Now all the discrepancies go out the window.
Well,
So it's perplexing for me. It's very perplexing that people don't at least acknowledge that.
I think it's crazy to include mass at all as a dynamic cause of anything, just because mathematically it can be derived out as like the second thing that Cassandra ever taught us, right? Was the derivation of Kepler's law from Newton, so we could be like, wait a second. So the thing that's the dynamic cause, when you equate gravitation to centrifugal, it disappears, it cancels out, so it's negligible, it doesn't matter. Well, how can it both be negligible and not matter and algebraically cancel out and be the most important dynamic cause of everything that happens in the sky? And then quickly you're like, oh, it can't be both those things. So obviously, like, to even say that it is, to bank everything on the fact that mass is moving everything in the sky, proportionate or not, is crazy to me, because obviously it's not even necessary.
It's literally a house of cards. It's like built on a lie. Because
I think
that's
the
the first
missing
time I
mass
used
doesn't
it.
really sell it. Like maybe
Right.
maybe come up with something else that sort of hits better. Because missing mass doesn't really do it for me. So let's just switch it to dark matter. You gotta sell it, you know.
Yeah. Yeah, it's like a promotion.
And missing mass, you gotta come up with a better marketing campaign than missing mass. That
Yeah,
kind of
dude.
makes it seem like we were wrong.
The PR team had to hit it with the rebrand. They're like, this is too obvious. People know we messed up. Let's just make it sound cool.
Recall.
It's dark and mysterious.
Now what I've been hearing a lot lately is dark matter isn't just a made up thing. We have dark matter observations. And I'm like, wait. Doesn't the dark specifically mean we can't observe it? Yeah, we have dark matter observations we can't observe. Bro,
I
it's
think dark
weird.
matter is more of a feeling.
It's
More something you experience.
An invisible feeling observation with a good feeling or whatever. There you go.
Look, I have some really precise instruments that would measure the dark matter. I don't have them right now or know their names, but I'm gonna.
Actually, other people have used my super sensitive experiments to make the observations that I haven't made that prove the thing that I'm trying to prove, but I can't. I think of any at the moment.
That's funny.
Actually, I learned. Well, it's not really a fallacy, but I learned this when I was listening to Austin debate on the FED server. Someone was sort of chiming in different fallacies, and she said, well, that's an appeal to future fallacy. So I'm like, oh, that's new to me. Let me look that up. So I look it up, and the only site that I could really find was flatearth.ws. And it's the, hang on, let me just get this real quick for you guys. Have you ever heard of that? Appeal to future fallacy?
No.
So that
I
is,
didn't.
it's on flatearth.ws, which is like the flat earth debunking website. The fallacy of an argument to the future occurs when someone claims their argument is true because of the false assumption that the evidence is in the making and it will soon be proven true.
Yeah.
But like missing mass is an appeal to the future or escape to the future fallacy then, because it's like, just you wait till we figure it out. Like the graviton.
I have faith that someday I'll invent a fake particle that will corroborate the thing that I have failed to prove today.
Just you wait till we reify that one. Don't you worry.
What a statement. And then if not, I'll have other fake particles that will corroborate other fake particles, and I'll hang my head on that.
Yeah.
What about the all the names for the particles? Like you have like the gotta keep Earth motion a ton. The whoops thought it was moving really slowly a ton. The it's definitely moving around the sun a ton or whatever.
Pseudoscientific ton. They got all kinds of them.
That's so funny. Got to keep Earth moving.
Speaking of the future, what do you think about this? I mean, with the Candace Owens and Alex Stein, is that a plan or
What do you mean? Is that
not a real plan? I mean, is that not a real
like going
plan?
to Antarctica? People are speculating about that.
Candace is sending someone from her team, and I think Alex is considering it. He called me a couple days ago.
I want to know about Candace. She's the man. So
Can oh my goodness, Candace isn't going. Candace is sending someone on her team.
all right.
But they're going there under the assumption that it's for this 24-hour sun.
Can we not talk about Antarctica right now?
Yeah, well, Cassandra, that was good. I was great for you to agree to do this. I didn't know you were going to do this. I was super excited to come and hang out and listen to you talk to what other people thought was some equivalent or an actual competitor, but who we all knew you would destroy. So that was great to watch.
I thought it was really simple. I liked it a lot. I liked listening.
Yeah, it's fun to hear ridiculous, just like, hold on, can I get on this tiny island? Can I fit my whole body on this little toe shit? Can I just stand here for the whole fight and kick you in the shin or whatever? It's fun to see a grown man adopt that position in a debate, but I didn't think that would happen, but I think he handled it pretty well. Is that what you call it? That's actually a really good term. I was thinking about that. I saw that in the comment. But is this two Globers against it? What? What? Are you not
What is
listening to any of
purity
the discussion
spiraling?
going on?
All or nothing.
Good super chats, guys. But yeah, I mean, Dr. Bennett. I mean, I don't want to say declare a winner as if it was a debate or not. Dr. Parks made some good points and some good, arguments as well. But if you had to weigh out a winner, his refusal to concede to very specific logical points that you were making I would say make you the winner. The concession that we have laws of physics that went in an inertial reference frame, therefore, and then his refusal to concede to the kinematics versus dynamics would make you the clear winner. But it was still an interesting conversation.
Well, no thanks. If you had to award points, right, to both sides from 0 to 100, how would you score it?
Yeah, I mean, I would probably say like 70, 30 or 65, 35 or something like that.
Wow.
I mean, what could you say the points were for Parks? I mean, it was just his closing statement that we have a bunch of evidence.
Yeah, almost
a bunch,
none.
Yeah, I mean, he would just.
Anyway, what were you saying?
Yeah, I mean, his best points were that we have a lot of people agreeing with us. Those were his best points.
What's it called when you miss a free throw? You don't get any points. What's that called?
When you brick a free throw, is that what you said?
Yeah, when you just airball it, do you get like a complimentary point or no?
No.
Oh my god, a complimentary point. Watch the dude. Listen, it's Thursday night football right now. You got to get back into complimentary points. Is not a thing in sports.
I only watch Bad Men Brothers.
He was trying to make a joke. Hey, I'm sorry about this, but let me read these again because apparently they couldn't hear me. And I'm gonna do it really fast. I'm sorry, but Gordzilla, thank you for super chat. Glinda Safkin, thank you for super chat. LUM, thank you for super chat. Thanks, gentlemen. Audience, please practice impartiality and objectivity for future debates and be respectful in the chat. Insults and bickering is reactionary and is not respectful or productive. Blessings. Thank you. Much love. Thank you for the kind words and the wise words. Sorry. Like you guys heard me, they didn't, so I don't want to leave them hanging.
Oh yeah, we heard you
Oh,
guys.
to
Yeah,
the
no,
lads.
good super chat.
All right, well, I think I'm about to wrap up here. Does anyone have any questions for Bennett before we dip?
Yeah, when is your next debate, and how do I get a front row seat?
Well, this wasn't a debate.
Right. Well, your next
But
discussion.
the thing is, I require, as I mentioned at the beginning, that there be some common ground, and what that would include is, like I said, a discovery session where you indicate what topics or what experiments you're going to use, not what your reasoning is going to be, but simply stating, what are you going to use as references. And I also said that philosophy should include realism, because otherwise there's no sense in debating with someone who doesn't believe in science, experimenting, and proving by induction. So that's one of the require. Oh, and a statement of what the hypothesis is. See how we didn't really discuss geocentrism because it really wasn't defined. He sent me an email where he said it's a preferred position in the universe, but that didn't seem to be what most people think geocentrism means. And we didn't define it. So if you don't define what you're talking about, as you can see, you can spend 3 hours going around in circles because you're not really having a common ground or belief. I mean, talked in different languages, we couldn't communicate at all. Even if we don't speak English, we still have beliefs about the way the world works that differ. And if some of those become impossible to resolve, and it isn't really um, sensible to have a debate. Only with someone who has a philosophical outlook on the world is someone that are people that you can debate with. That's what I would require from a debate, and that's it.
Nice.
Yeah,
Well, just to clarify, so you are open to debating, I don't know, PhD astrophysicist, astronomer, or someone like that. If the person agrees philosophically on realism, that basically not only does truth exist, but that it can be attained, and agrees to the scientific means of doing so, and that they would agree to formulating a specific hypothesis that the discussion's actually going to pertain to, and then having like a discovery process prior to the debate where both parties give each other any and all experiments, or basically evidence that would be invoked during said debate. Is that correct?
Right. Right, and the moderator enforces that. So if anyone brings up a topic that wasn't on the list, which is given to the moderator, then the moderator can flag it. The
Oh, very cool.
scientific method itself, yeah, the scientific method itself has flaws. It requires, number one, that experiments be repeatable. So one-off events cannot be tested by the scientific method, right? Also, Scientific method does not believe that you can accept the testimony of trusted people. We live our lives trusting certain people. We have our own epistemology. We have our own ways of judging people. We do accept, because we have to live in this world, the testimony of people who we consider trustworthy. Scientific method doesn't include that at all. Philosophy does. Philosophy says that if you have credible testimony from an observer, you can use that in building your philosophy, your belief system. And that's what the scientific method lacks, the ability to deal with one-off events or with testimony from observers, which cannot be done with physical experiments.
Makes sense. All right, cool. Alan, are you want to get any final words in?
I'm good, man. It was a long conversation that went by really slowly. Starting to believe in time dilation now after that, and relative reference frames. Maybe it's true. Maybe I overlooked something. I'm going to go back and read Einstein's paper again, see if I missed anything.
And therefore,
It was like a golf match that just, never ended.
I do have some hard-hitting questions if you guys want to entertain them.
Oh,
yeah, so,
Is it where you get your coffee?
Yeah, I was thinking it's gonna be a late night for me. Where would you guys go to get a nice cup of coffee that is or maybe isn't made with baby penguin parts?
Brushtails.coffee.
When I want a nice cup of Joe, I always ask Liliana what she would recommend to drink. Lily, are you there?
Hey, hello. Yes, I'm here. Hi. Yeah, so my favorite coffee is the brush tail. I really enjoyed the Ethiopian and also the I think there was one from Tanzania. That was really good. And then I just got the Honduras, which I've not opened yet. Yeah. But real quick, what's it? Your theory that you were just proposing about like using the magnetism difference, to explain the lack of the mass in the galaxies and all that. You should try and sell that concept to mainstream science for big money. I'm telling you, I think that you could help them out. It's just a joke.
Yeah, I'm sure they'll line up to really put a lot of money in my pocket.
Yeah, why didn't we think of that?
Why didn't you think about getting rid of mass, man? Come on. Yeah, Brushtails Coffee. That's brush. You want to say the website accurately so I don't mess it up?
Brushtail.coffee.
Brushtail,
Toby
no
makes
S.
it to order.
Yeah, it does. And you don't get one of those stupid expiration dates. You get a roast date. You're basically royalty.
Expiration date makes me sick.
Dude, I can't even look at coffee in the grocery store anymore.
I'll save my testimonial for next time, but I do have a testimonial.
Yeah, if you're drinking Maxwell House, don't even talk to me.
I actually unfriended everyone from Facebook and MySpace that drinks Maxwell and stuff like that. I was like, yo, any expiration date lads in the chat? And everyone that said yes, I just deleted them all. Anyway, Lily, what was your testimony?
Very nice.
Oh, we could save it for next time.
Word. All right. Well, quick shout out to the Flat Earth Gang on Clubhouse. If you're not on the Clubhouse app, then that's one app in your phone that you should definitely have. And then also tomorrow will be Flat Earth Fridays, episode 115. So make sure you check that out. We'll be live at 8, give or take. Then on Tuesday, I think Shane has a presentation coming up on something. Then Wednesday will be Shane's debate with optics with a guy from Twitter. And then on Thursday, Mordwand and I will be debating on quantum electrodynamics.
Wow.
Did you say? Did you give an auditory boo?
Wow. Oh man, tell him I need my 1777. All right, cool. I'm
I'll
gonna
see if I can put it in.
Yeah, I'm gonna deafen here real quick and then wrap up the stream and I'll pop back in here.
Word. I'm closing mine out now.
Have a great
guys, see you
job.
tomorrow.
Shout out to Dr. Bennett. He crushed per usual. Definitely keep up with some of his work if you are unfamiliar. All right, cool. Hopefully you guys enjoyed. I rushed that stream together. I got here kind of late, so we just like really rushed the stream together. It is what it is. But I think it was cool for it to not be a debate, but it's just a discussion, or whatever. I think the recap kind of covers it a lot, but it's very interesting. When it comes down to it, you really get into it. A lot of people are like, oh, FE is so easy to prove, and like all these nerds want to talk about all this stuff in the weeds. Some people actually enjoy physics and want to understand how the world works and wants to figure out like what's really going on. And there's this higher level of the discussion that takes place. And there's this narrative that goes around like that flat earthers or geocentrists aren't a part of that world at all. That's completely untrue. In fact, they actually dominate those discussions. Their positions are, in the sense that their positions are way more bulletproof, are way more empirically centered, etc. So I'm all for dispelling that notion, that illusory, tactic used against dissenting ideas, because it's super lame and it's just a tactic. It's a tactic to avoid the inability to provide substantive specificity in the form of rebuttal or refutation to the actual positions of the other side. Typically, that side doesn't understand their own side, much less can they provide an actual, accurate, valuable stillman, which means they're in no position to even come to a conclusion, much less confident assertions. So I am pretty tactical with stuff I do. I'm a big fan of Mr. Bennett, and I think that he crushes. So thank you to everyone who supported the stream. I don't think I'm missing any tips. You can go to Ko-fi.com/Witsit. I can double check. I think I may have got one thing on Ko-fi. Obviously, I'm still getting attacked there. Our subscriptions are still randomly ending. I don't know what's going on. It's just so annoying. Tony Coriolis, thank you for the $10 on Ko-fi. Ko-fi.com/Witsit. I'm going to do a stream soon. We're bringing Skull and Globers back. We're going to start a new geocentrism thing. Starting pretty frequent debates back up. Really big show. I'm supposed to be on here soon. So stay tuned. Lots of content coming soon. I've said that for a little bit. We're a little behind, but just trust me here. When it all starts, you'll be like, you'll forget that there was a little period of time where I was super busy having to run away from a hurricane. So cool. Hopefully you guys enjoyed the show. I won't talk too long, but I love you guys. Seek and speak truth unequivocally. The weak find contentment in the consensus of ignorance. So who cares what other people think? They're always going to attack you whenever you challenge the status quo, whenever you think for yourself. Certainly, sometimes people are envious of your ability to do that, to think for yourself, to not have anything to hide, to be intellectually secure enough to be able to reason live time and to be open to new information. And when you basically lack that confidence, it's been dwindled down, and innovation and creativity has been like sucked out of you from a young age. You have to build up this like facade of confidence behind this illusory shield of consensus, and that's lame. Who cares about people that do that? I hope people realize that they do it and they can step out of it. All right, cool. I love you guys. And just remember, what's popular is rarely true, and what's true is rarely popular. Till next time. Peace.
That's for Israel. Wonder, is it real? Rappers acting say they high, say they sipping pills. Glorify suicide so they get the deals. Big pharma set it up, had to flip the pills. Control the music in the forceful grip. They force a misinfo that we absorbing quick. Took the people's signature to mean extorted it. They forging it. If news ain't good, informants who informing them. There's a surplus, but they tell us there are shortages. Credit economy mortgages, dollar that's supported with empty fortresses. But what's important is this: we porting ships, important gifts. Of course it is what extortion is, in accordance with an assortment list of foreign tricks. We ignoring which informant this, informant this. It looked like we were snoring tricked. Pedophilia and the government endorsing it. Yeah, eugenics is exactly what abortion is. You just vilify those insubordinate. Way to matrix engineer, that's unfortunate. Geopolitically we in a field that's for Israel. Wonder is it real? Rappers actors say they high, say they sip with pills. Glorify suicide so they get the deals. Big pharma set it up just to flip the pills. Control the music industry until the scripts get filled. Geopolitically, yeah, we in a field that's for Israel. Wonder is it real?